All right, let's take a look at our practice test. We're told to solve each equation. So when we look at the first problem, we have x plus 10 equals 12. So how can I solve this equation? Remember, if you solve an equation, you want to isolate your variable on one side. Usually I use the left, but you could put it on the right if you wanted to. So you want x equals some number, right? So my goal is to have x equals some number, okay? And then if you plug in that some number for x in the original equation, you get a true statement, meaning the left side is equal to the right side, okay? So how do we do this? How do we get x by itself? Well, again, we're going to use inverse operations. So what's being done to x right now on the left is I'm adding 10. How can I undo that? Well, if I'm adding 10, I need to subtract 10 away. So in other words, I would go x plus 10. Let me do this in a different color. You can go plus negative 10 like this, or you can go minus 10, whatever you want to do. It's the same thing. And then you can go equals 12. And now here's the key. Since I did this to the left side, to maintain my solution set, I've got to also do this to the right side. So plus this negative 10, okay? If I don't do this step over here, this doesn't work, okay? So I've got to do it to both sides of the equation. Now, on the left side, what is going to happen? The 10 plus negative 10 is 0, right? So you basically have x plus 0, which is just x, right? Adding 0 to something doesn't change it. So you can really just line this out if you want and say I just have x, and this equals, now 12 plus negative 10 is going to give you positive 2. Okay, so my solution here is x equals 2. Sometimes in some courses you'll write this in solution set notation. So you would put a 2 inside of set braces. It's really up to your teacher. But if you want to check this, let me erase all this. I'm just going to write x equals 2 here. And I'm just going to check this first one. You can check the rest on your own. You're going to take your solution and you're going to plug it in for x in the original equation. And you're going to make sure the left and right sides are equal. So in other words, if I plug in a 2 for x there, I have 2 plus 10 on the left equals 12 on the right. If I simplify, 2 plus 10 is 12, so I get 12 equals 12, which is a true statement. Okay, so that's how I check my solution for the equation. Okay, let's look at problem number 2. So I have x minus 5 equals negative 3. Again, I want x by itself on the left-hand side. So what's being done to x? I am subtracting 5 away. How do I undo subtraction? I add. So I have x minus 5. What I'm going to do is I'm going to add 5 equals negative 3. Again, to make this legal, let me do this in a different color so it's clear. I'm going to put plus 5 here. I've got to also do it here, okay? So to maintain the balance, you got to do it to both sides of the equation so it's legal. On the left, this is always just going to cancel, right? I undid what was being done to x. So this right here, you could say it's 0, so x plus 0 is always just x. And this is equal to, on the right side, negative 3 plus 5 is going to give you 2. So again, we get a solution of x is equal to 2. Again, if you want to write the solution set notation, you can put a 2 inside of some set braces. All right, let's look at problem number 3. So we have x plus 1 equals 9. Again, what's being done to x? We have this plus 1 here. So x plus 1 is equal to 9. To undo the addition of 1, I'm going to subtract 1 away. So you can put minus 1, you can put plus negative 1, again, however you want to structure it. But whatever you do, you have to do the same thing over here to maintain the balance. So I'm subtracting 1 away from here, subtracting 1 away from here. 1 minus 1 is 0. So on the left, I just have x. On the right, I have 9 minus 1, which is basically going to be 8. So x here would be 8. All right, let's look at problem number 4. Here we have x minus 1 equals negative 7. So what's being done? We're subtracting 1 away. The shorthand notation is you can just add 1 in line here, like this. If you prefer the horizontal, so x minus 1 plus 1 equals negative 7 plus 1 like this. If you've got to do that for a while to make it make sense, that's fine. Again, you're just doing the same thing to each side, doing the same thing to each side. This is a little bit easier to show things because you can cancel this like this and say that I have x is equal to negative 7 plus 1 is going to be negative 6. So that's going to be my answer. All right, let's look at question number 5. So we have x plus 3 equals 14. Again, what's being done to x? I'm adding 3 to it. So I'm just going to do the opposite of that. I'm going to subtract 3 away from each side of the equation. Let's go ahead and cancel this. And I'll say x is equal to 14 minus 3 is going to be 11. So that's my solution. All right, let's get to question number 6. So I get a lot of people that actually send complaints to me about this. They say this is not solved using the addition property of equality, which isn't actually true, okay? So you just have to use some thinking here. We have 3x minus 10 equals 2x minus 5. I can completely solve this equation using only addition and subtraction. All I have to do is think about how to get all the variable terms or the terms with an x in it to one side. So I could subtract 2x away from each side of the equation. That is completely legal. And actually, let me do this horizontally first so that people see what's going on. So let me do this down here. So 3x, I'm going to go plus negative 2x, and then I'm going to go minus 10 is equal to 2x. I'm going to go plus negative 2x, and then I'm going to go minus 5. So what did I do? I added negative 2x to both sides of the equation. That's just using the addition property of equality. I didn't do anything else, okay? So 3x plus negative 2x, we know how to combine like terms. This is just x. That's all it is. Then I have minus 10 is equal to 2x plus negative 2x is 0. So if I had 0 minus 5, that's just negative 5. So this right here now is in a format that we know how to solve from this section, okay? So let's come down here and look at this now. And so basically, I would just what? I would add 10 to both sides of the equation because, again, what's being done to x? I'm subtracting 10 away. So to undo that, you just add 10 to both sides. This cancels, and you get x is equal to, this would be positive 5. Again, if you want to check this, you could plug a 5 in here and here and verify that you get the same number on both sides of the equation. And let's just go ahead and do that for the sake of completeness, just for this other example. So this would be 3 times 5 minus 10 is equal to 2 times 5 minus 5. So 3 times 5 is 15. So you'd have 15 minus 10. 15 minus 10. So this is 5. Over here, 2 times 5 is 10 minus 5. So 10 minus 5 is 5. Same number on both sides of the equation. So you can say that your solution x equals 5 is correct. All right, let's look at problem number 7, solved in a very similar way. 2x plus 9 equals x minus 3. Again, I'm just going to subtract x away from each side. And really, if you wanted to, you could do this now. You're just going to subtract 9 away from each side. So I'm just going to cancel this, and I'm going to cancel this. So 2x minus x is x, and that equals negative 3 minus 9 is going to be negative 12. So that's my solution right there. All right, problem number 8. Again, similar strategy. 5x plus 4 equals 4x minus 7. I have a 5x and a 4x, so let me just subtract 4x away from each side of the equation, and then let me subtract 4 away from each side of the equation. So this is going to cancel, and this is going to cancel. So what does that leave me? 5x minus 4x is just x, and that equals negative 7 minus 4 would be negative 11. Let me make that a little bit cleaner, so that's my solution. Okay, let's look at problem number 9. So here we have 2x minus 11 equals 3x plus 6. Now, I like my variable on the left. So what happens if you subtract 3x away from both sides of the equation here? Well, you're going to end up with negative x because 2 minus 3 is negative 1, right? So this is negative x, and then minus 11 is equal to 6. In the next section, we're going to talk about how to solve something when the coefficient is not 1. Most of you already know how to do it because you're in a college algebra course. But the other way to do this would be to send this to the right side. So in other words, to start the problem off in a different way and say, okay, well, I'm going to subtract 2x away from both sides. And what's going to happen is this will cancel over here. 3x minus 2x would be x. And then let's put this as equal to, you have negative 11 here, and then plus 6. And then I could subtract 6 away from each side here. Let me scroll down a little bit. And basically, this cancels, and you get negative 11 minus 6, which is negative 17, is equal to x. I can flip this around legally and write my answer as x equals negative 17. Okay, that's really up to you. In the next section, we'll talk about this. If you had done it the other way, and let's say you subtract 3x away from both sides of the equation, and let's add 11 to both sides of the equation, well, what happens is this cancels and this cancels. So you have negative x is equal to 17. And really all you have to do now is multiply both sides by negative 1. So basically you treat this, you say negative 1 times negative 1 is positive 1. So this is x is equal to 17 times negative 1 is negative 17. Okay, so this is another way you can do it. We're not going to talk about the multiplication property of equality to the next lesson. For right now, you can do it the other way. So this would be your solution. X equals negative 17. Okay, let's look at the final problem. So we have 9x plus 1 equals 8x minus 13. Again, I'm just going to subtract 8x away from each side of the equation. Get rid of that. I'm going to subtract 1 away from each side of the equation. Get rid of that. 9x minus 8x is x, and this equals negative 13 minus 1 is negative 14. So that's my solution. All right, let's take a look at our practice test. We're told to solve each equation. For problem number 1, we're given 9x equals 18. What's being done to x? In other words, if I want to get x by itself, what do I need to undo? So if I have 9 times x equals 18, well, the opposite operation or the inverse operation of multiplication is division. So what I could do is I could divide both sides by 9, or I could multiply by 1/9. You could do that as well. So what happens is if I divide 9 by 9, I'm undoing what's being done to x. So this cancels with this. It gives me a 1. 1 times x is just x, right? 1 times any number is just itself. So now I have x by itself, which is what I want. And this equals 18 divided by 9 is going to give me 2. So this would be my solution there. Again, you could just plug it in. 9 times 2 is 18, right? So you would have 18 on the left and 18 on the right. So that's a true statement. Okay. And again, if you want to write this in solution set notation, I'll just do it for this one. You can put this inside of set braces. Some classes make you do that. I'm just going to stick to this notation for today. All right, let's look at problem number 2. So here we have negative 4x equals 52. So what's being done to x? I'm multiplying it by negative 4. How do I undo multiplication? I do division, right? So I would divide both sides by negative 4. Or again, you can multiply by negative 1/4 if you want to do it that way. It's really up to you. And so from here, let's just go ahead and cancel this negative 4 with this negative 4. That's 1. So you have 1x, or just x, is equal to, what's 52 divided by negative 4? Well, that's going to give me negative 13. So that'll be my answer. All right, let's look at problem number 3. We have 1/4 x is equal to negative 19. So 1/4 times x is equal to negative 19. Since I have a fractional coefficient here, it's easier just to think about multiplying both sides by the reciprocal. Remember, if I multiply a number by its reciprocal, I get 1. And that's what I want here. I want 1x, or just x. So the reciprocal of 1/4 is 4 over 1 is just 4. So if I multiply this side by 4, then multiply this side by 4 to make it legal, what's going to happen is this is going to cancel with this, and I have 1 times x, which is of course just x, which is what I want. And it equals negative 19 times 4 is going to give me negative 76. So x equals negative 76 is my answer. All right, let's look at problem number 4. So here we have negative 12x equals 144. Again, this is very simple. We're just going to divide both sides by negative 12. That's my coefficient of x, or what's multiplying x. And what's going to happen, again, negative 12 divided by negative 12 is 1. 1 times x is just x. So x equals 144 divided by negative 12 is negative 12. So this is my solution. All right, let's look at problem number 5. So here we have negative 4/5 x equals 20. So again, negative 4/5 times x is equal to 20. Again, you can divide both sides by negative 4/5, but it's quicker just to multiply by the reciprocal, again, if you have a fractional coefficient. So I can say I'm going to multiply by negative 5/4. Again, a number times its reciprocal is always 1, and 1 times x will just be x. To make it legal, let's do it to the right side. So negative 5/4 over here. And let's go ahead and cancel. So these are going to cancel. That's just 1. 1x is just x. And this equals, this would cancel with this and give me 5. 5 times negative 5 would be negative 25. So x equals negative 25 is my solution. All right, let's look at problem number 6. Here we're going to combine our addition property of equality, which we talked about in the last lesson. So we have negative 5x plus 2 equals negative 13. So I can't solve this with just straight multiplication or division like I've been doing. I need an additional step. If I want to isolate my variable x, I first have to isolate the term that contains the x. So in other words, I need to isolate this negative 5x first. So how do I do that? Well, what's being done to that? I'm adding 2 to that. So I can subtract 2 away from each side of the equation. Let me come down here, and I can just say, okay, well, this is going to cancel. 2 minus 2 is 0. If I add 0 to something, it's unchanged. So now I have negative 5x is equal to negative 13 minus 2, and negative 13 minus 2 would just be negative 15. Okay, so now this is in the format that we're used to solving today. Again, what's multiplying x here is negative 5. So I'm just going to undo that by dividing both sides by negative 5. And again, this is going to cancel with this and give me a 1. So this is x is equal to negative 15 over negative 5 is positive 3. Again, you can always check this x equals 3 solution by plugging that back in for x and seeing if you get the same value on the left as on the right. I'll leave that up to you to do. All right, let's look at problem number 7. So here we have negative 5x equals 15x plus 10. So here you have an x here and you have an x here. So if this happens, you've got to collect all the terms on one side of the equation. So to do that, I'm just going to subtract 15x away from each side of the equation. So what is 15x minus 15x? Well, that's going to be 0, right? So I'm just canceling it from here. And basically on the left side, you now have negative 5x minus 15x. Those are like terms, right? So basically negative 5 minus 15 is negative 20, and x comes along for the ride, right? So I just have negative 20x. And then this equals this 10 over here. And then again, what do I need to do to get x by itself? Well, I'm multiplying x by negative 20. So to get it by itself, I'm going to divide both sides by negative 20. And then this is going to cancel with this, and I'm left with 1 here. So 1x is just x, and this equals 10 over negative 20 is negative 1/2. So x equals negative 1/2 would be my solution. All right, let's look at problem number 8. So we have 9x equals 5x minus 12. And again, I'm just going to subtract 5x away from each side of the equation so I can get everything with an x on one side. This is going to cancel. 9x minus 5x, again, they're like terms. 9 minus 5 is 4. X comes along for the ride. This equals negative 12 now. Again, what's being done to x? It's being multiplied by 4. So divide both sides by 4. Okay, and basically 4 divided by 4 is 1. So now you just have x by itself on the left. And this is equal to, on the right, negative 12 divided by 4 is negative 3. So my solution here would be x equals negative 3. All right, for problem 9, we have negative 10x minus 133 equals x minus 1. All right, so again, in this particular case, I've got to get all the x's to one side. Let me subtract x away from each side. At this point, you could simultaneously add 133 to each side, but let's just maybe take it easy. Let's get rid of this first. Negative 10x minus x would be negative 11x. Then minus 133 is equal to negative 1. I'm just going to do this in multiple steps so nobody gets lost. And then from here, again, if I want to isolate x, if this is my goal, then I first have to isolate the term that contains x. Okay, so I need to isolate the negative 11x first. So what's being done to negative 11x? I am subtracting away 133. Okay, so to undo that, I'm going to add 133 to both sides of the equation. This guy right here is going to cancel, right? That's gone. That's just 0 now. So I have negative 11x is equal to negative 1 plus 133 is going to be positive 132. And then now I want to get x by itself. So what's being done to x? I'm multiplying it by negative 11. So to undo that, I'm going to divide both sides by negative 11. We know negative 11 divided by negative 11 is 1. So this is just x is equal to 132 divided by negative 11 is going to be negative 12. Okay, so x equals negative 12 is my solution. All right, let's look at 10, which is our last problem. So we have 5x plus 1 is equal to negative 5x plus 6. All right, so again, move all your variable terms to one side. So I'm just going to add 5x to both sides of the equation. And if you want to, you can do this now. If it's confusing, you can wait, do it in the next step. But you're going to have to move this constant here to the other side. So I need to subtract 1 away from each side of the equation. So this is going to cancel, and this is going to cancel. And what I'm left with on the left is 5x plus 5x, which is 10x. And this equals 6 minus 1, which is basically 5. So from here, again, what do I need to do to undo what's being done to x? Well, we have this 10 that's multiplying x. So all I have to do is divide both sides by 10. And what do I get? I get x is equal to, let me show this visibly that this is going to cancel and become 1. So x is equal to 5 over 10, that's just a half. So my solution here is x equals 1/2. All right, let's take a look at our practice test. We're told here to solve each equation. And for the first problem, we're going to be looking at 11x plus 5x. We're setting this equal to negative 3 multiplied by the quantity x minus 7. Then we're subtracting away 6 multiplied by the quantity 1 minus 4x. All right, so hopefully by the time you get into this college algebra course, you've had a lot of experience with solving equations, and this is a refresher for you. If you haven't, you can use a little simple 4-step procedure that gets you the correct answer each time. So the first step is we want to simplify each side. And what that means is we're going to combine any like terms, and we're also going to clear any and all parentheses that we see using our distributive property. So let me slide down here just a little bit. And if I look on my left-hand side, I see I have like terms. So 11x plus 5x, I'm just going to simplify that and make that into 16x. Okay, on the right-hand side, I can remove the parentheses in each case just using my distributive property. So negative 3 times x would be negative 3x. And then negative 3 times negative 7, I'll say that's plus 21. And then I'm going to treat this as negative 6 so I don't make a silly sign mistake. I'll say negative 6 times 1 is negative 6. And then I'll go ahead and say negative 6 times negative 4x is plus 24x. Okay, so the right-hand side is not fully simplified because what you can see is that you have like terms here and here. And then you also have these numbers or constants here and here. Okay, so let's just go ahead and simplify a little bit further and see what that gets us to. So on the left-hand side, you just have 16x. I can't do anything with that. That's as simple as I can make that. On the right-hand side, negative 3x plus 24x, that's going to give me 21x. And then 21 minus 6 is going to give me 15. So let me put plus 15 like that. Okay, can I do anything else on the right? No, 21x and 15 are not like terms. On the left, I just have a single term, 16x. Okay, so that's the end of the first step. The next thing you want to do for step 2 is you want to move all your variable terms to one side and all your numbers, or you could say your constants, to the other. It's a matter of personal preference, but I like my variable to be on the left. So what I'm going to do in this case is subtract 21x away from each side of the equation. Remember, you have to do it to both sides to make it legal. So I subtracted 21x away from here and also here, and that makes it legal. It maintains the balance, and you maintain your solution set. So I'm just going to cancel that away visibly here. 16x minus 21x, if I do that on the left-hand side, that is going to give me negative 5x. And I'm going to set this equal to, on the right, what's left is just 15. Okay, so now we get into our third step, and that's to isolate the variable. So let's look at x and let's think about what is being done to x right now. I can scroll down here a little bit, and I could write this really as negative 5 times x, so this is crystal clear, is equal to 15. Well, if this negative 5 is multiplying by x, to undo that, I need to use division. So I'm just going to divide by this coefficient of x, which is negative 5. And again, to make this legal, I have to do this to both sides of the equation. So I divide by negative 5, divide by negative 5. Now, what I'm going to do here is cancel this with this. That's a positive 1. And positive 1 times x is just x. So this is now x equals, in this case, 15 divided by negative 5 is going to give me negative 3. Okay, so this is always the format I want to get this into. X equals some number. So x is isolated on the left-hand side, or if you want to put it on the right, that's up to you. And then on the other side, you just have some constant or some number. So x equals some number. In this case, x equals negative 3. Now, the fourth step is optional. This is where you check your work. I'm going to do it for this first one, and then if you want to pause the video for all the rest of the problems and do it on your own, that's going to be up to you. All right, so let me write down that x was equal to negative 3. This is our solution. And to check this, I'm just going to plug this in everywhere there's an x. So a negative 3 there, and also there, and also there, and then also there. So if you got the correct solution, then basically the left and the right side will be the exact same number. Okay, so if you didn't get the right answer, then you'll have some mismatch there. So let's go through and crank this out. 11 times negative 3 is negative 33. And then 5 times negative 3 would be negative 15. So plus negative 15. Let me make that a little bit better there. And this is equal to, over here, negative 3 minus 7 is negative 10. If I do negative 10 times a negative 3, that's a positive 30. Then over here, let's treat this as negative 4. So negative 4 times negative 3 is positive 12. And then you would basically have 1 plus 12, which is 13. And let's treat this as negative 6. So what is negative 6 times 13? Well, that's going to be negative 78. So let's put minus 78 there. And then essentially what's going to happen is on the left-hand side, negative 33 plus negative 15 is going to give me negative 48. On the right-hand side, 30 minus 78 is also negative 48. So you can see that I have the exact same value on the left as I do on the right. So that's how you know you got the correct solution. So we can verify here that x equals negative 3 is correct. Okay, let's look at the second problem. We're just going to pick up the pace a little bit. So let's come down here. On the left-hand side, I know that 10x plus 2x would be 12x. So let's go ahead and simplify that. On the right-hand side, again, I can use my distributive property to remove parentheses. So I would have 3x, and then minus, this would be 30. Right? So 3 times x is 3x, and then 3 times negative 10 is negative 30, or you could say minus 30. Then over here, I'm going to bring the sign with me. So I'm going to say this is negative 7 times 5, that's minus 35. And then negative 7 times negative 2x is plus 14x. Okay, so I can continue to simplify on the right-hand side because I have some like terms here. So 3x plus 14x, let's just say that's 17x. And then negative 30 minus 35 would be negative 65. So let's put this like this. And then on the left-hand side, I just have 12x. On the right-hand side, I have 17x, and I have basically negative 65, right? But those are not like terms. You can't really do anything else with that. So my next step is just to move all the variable terms to one side and all the numbers or constants to the other. Again, as I said, I like my variable to be on the left. So I'm going to subtract 17x away from each side of the equation. And then essentially, this is going to cancel right here. Okay, so that's gone. And basically on the right-hand side, you just have the negative 65. On the left-hand side, you have 12x minus 17x, which is going to give me negative 5x. And again, once we get to this third step, we just want to get it to where x is completely isolated. Again, if this is x here, what's being done to x? Well, -5 is multiplying x. So to undo that, I just want to divide both sides by -5, whatever that coefficient of x is. So this is going to cancel. And again, it's going to become +1, and 1 times x is just x. On the right-hand side, we have this -65 divided by -5, and that's going to give me +13. So this would be my solution. Again, if you want to, you can always pause the video and check the solution on your own. All right, let's look at problem number 3. So here we have the negative of the quantity 2 minus 10x is equal to 8 times the quantity x minus 5. Let me slide down here a little bit. If you see a negative in front of parentheses, just treat it as if you had a -1 outside of there. And basically, you're going to change the sign of each term inside. So the 2 becomes a -2, and the -10x becomes a +10x. And this equals 8 times x would be 8x, and then 8 times -5 would be -40. So in this case, I can't do anything else on the left or on the right because we don't have like terms, right? -2 and 10x, not like terms. 8x and -40, not like terms, right? So now we move into our step where we, again, move all the variable terms to one side, all the constants to the other. So I'm going to actually subtract 8x away from each side of the equation. And let's go ahead and cancel this out over here. So on the left, I'm going to have -2. And then 10x minus 8x is going to give me 2x. So let's put plus 2x. And this equals, over here, I'm going to have -40. Well, I need to isolate, again, my variable terms. So I want all the variable terms on one side, which I've done, and all the constants on the other, which I haven't done. I still have this -2 hanging out over here on the left. So what I'm going to do is add 2 to both sides of the equation to fix that. And let's go ahead and cancel this away. And we'll say that we now have this 2x on the left is equal to -40 plus 2 is going to be -38. Okay, so once you get to this stage, again, all you're doing is you're looking at the coefficient of x. You're saying, okay, since 2 is multiplying x, to isolate x or to get x completely by itself, we're going to divide both sides of the equation by 2. Again, the number that's multiplying x. And of course, this is going to cancel with this and give me a 1. So this is just x is equal to -38 divided by 2 would be -19. So x equals -19 is our solution. Okay, let's look at problem number 4. So we'll have 10 times the quantity 5x plus 8 minus 12x is equal to -11 times the quantity 1 plus 4x plus 9. All right, so again, I'm just going to clean up each side. Over here on the left, I'm going to use my distributive property. 10 times 5x is going to be 50x. Then plus 10 times 8 is 80. Then we're going to subtract away this 12x. Now, we know that 50x and -12x are like terms. And if I perform that operation, I'm going to get 38x. So let's put 38x and then plus 80 like this. Let's put equals and equals. Over here on the right, again, I can use my distributive property. -11 times 1 is -11. Then -11 times 4x is -44x. And then basically I just have this plus 9. Now, you see that -11 and positive 9 can be combined. That would be -2. So let's put -44x like this, and let's put -2 like this. Okay, so now we've completed that first step where we're simplifying each side. I can't do anything else on the left. I don't have like terms. I can't do anything else on the right. I don't have like terms. So what I want to do is move all the variable terms to one side and all the constants to the other. So I'm actually going to do this in one line. I'm going to move this guy over here. So I'm going to add 44x to both sides. So I'm going to do that. And of course, this is going to cancel. And then I'm also going to subtract 80 away from each side of the equation. And so what's going to happen here is that this guy is going to cancel. What happens is on the left, I just have my variable terms, and on the right, I just have my constants. Okay, so I just have to simplify. What is 38x plus 44x? Well, that's going to give me 82x. So let's write that we have 82x here on the left. On the right, what is -2 minus 80? That's going to be -82. And of course, once we have it in this format, we just want to divide both sides of the equation by the coefficient of x. So I'm going to divide both sides by 82. And we know that this is going to cancel already. Let me visibly show that. So 82 divided by 82 is 1. So we get 1x, which is just x, is equal to -82 over 82 would just be -1. So x equals -1 is our solution. Okay, let's look at problem number 5. So I have 4 times the quantity x minus 5 is set equal to -2 times the quantity x plus 1. So again, just use the distributive property to clean up first. you would have 4x minus 20. Again, 4 times x is 4x, and then minus 4 times 5 is 20. And this equals, over here, you would have negative 2x, and then minus 2. So negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. Okay, left and the right side, again, nothing else you can do. So you move on to move all the variable terms to one side and all the constants to the other. So all I'm going to do is add 2x to both sides of the equation. And then I'm going to add 20 to both sides of the equation. And so what we're going to see is that this guy's going to cancel and this guy's going to cancel. And what I'm left with is 4x plus 2x. That's going to give me 6x. This equals negative 2 plus 20 would be positive 18. Okay, again, once you get into this format, it's really easy. I see that 6 is multiplying x, so to get x by itself, I divide both sides by 6, and I end up with this canceling with this, and I get x is equal to what? 18 divided by 6 is going to be 3, so x equals 3 is my solution. Okay, let's look at problem number 6. So I'm just going to have 6 times the quantity 6 plus 12x is equal to negative 1 plus 7 times the quantity 10x plus 7. So on the left, I'm just going to use my distributive property. 6 times 6 is 36. Then plus 6 times 12 is 72. And then x will come along for the ride. This equals, you have negative 1 plus 7 times 10x is 70x. And then plus 7 times 7 is 49. We know that negative 1 plus 49 is 48. So let's just erase that and put a 48 there and get rid of this plus sign in front there. Let me slide this down a little bit so it looks a little bit cleaner. Okay, so that's as simple as we can make each side. So again, what you would do here is just move all your variable terms to one side, all your numbers or constants to the other. So let me subtract 70x away from each side of the equation. And let me also subtract 36 away from each side of the equation. Let me make that 3 a little bit more legible. And then let's cancel this. And then let's also cancel this. Okay, so what do we have? On the left-hand side, 72x minus 70x is 2x. On the right-hand side, 48 minus 36 is going to be 12. So again, very easy. Once we have it in this format, so 2x equals 12, we want to divide both sides by 2, that coefficient of x, and I'm going to get that x is equal to 6, right? 12 divided by 2 is 6. So x equals 6 is my solution. Okay, let's look at problem number 7. So we have 10 times the quantity 4 plus x is equal to 2 times the quantity 5 plus 2x. All right, so we would have 10 times 4, which is 40, and then plus 10 times x, which is 10x. This equals 2 times 5, which is 10, then plus 2 times 2x is 4x. Okay, so each side is simplified as much as possible. Again, very easy at this point. We would subtract 4x away from each side of the equation. I'm also going to subtract 40 away from each side of the equation. Let's go ahead and cancel this guy. Let's go ahead and cancel this guy. And what am I left with? On the left, 10x minus 4x is 6x. This equals, on the right, 10 minus 40 is negative 30. Let's go ahead and divide both sides of the equation by 6. Again, the coefficient of x. And we're going to get that x is equal to negative 30 divided by 6 is negative 5. So x equals negative 5 is my solution. Okay, let's look at problem number 8. So we have 9 times the quantity 10 plus 6x is equal to negative 12 times the quantity 1 minus 3x and then minus 6. So on the left, you would have 9 times 10, which is 90, plus 9 times 6, which is 54. X would come along for the ride. This equals negative 12 times 1 is negative 12. Then negative 12 times negative 3x is plus 36x and then minus 6. So negative 12 minus 6 would be negative 18. So let's just go ahead and erase that and put negative 18 here. And again, the left and the right side, that's as simple as I can make it. And so let's go ahead and subtract 36x away from each side of the equation. And also, let's go ahead and subtract 90 away from each side of the equation. So let's cancel this guy right here. Let's cancel this guy right here. So then 54x minus 36x is going to be 18x. And this is equal to, if I do negative 18 minus 90, that's going to be negative 108. And again, once you get into this format, you're just dividing each side by 18, the coefficient of x. We're going to get that x is equal to, we know negative divided by positive is negative, and then 108 divided by 18 is 6. So you would have x equals negative 6 as your solution. All right, let's look at problem number 9. So we have negative 11 times the quantity 10 plus 7x, then plus 9x, is equal to 7 times the quantity 1 minus 11x. Okay, let's come down here. And negative 11 times 10 is negative 110. Then I have negative 11 times 7x. This is negative 77x. Then plus 9x. Now, if I do negative 77x plus 9x, that's going to give me negative 68x. So let's just erase this and put negative 68x. Then this equals, over here, 7 times 1 is 7. And then minus 7 times 11x would be 77x. All right, left and the right side are as simple as we can make it. So again, let's just add 77x to both sides of the equation. And then let me add 110 to both sides of the equation. And let's go ahead and visibly cancel this guy right here and this guy right here. So on the left-hand side, I have negative 68x plus 77x, which is 9x. And this equals 7 plus 110 is 117. Now, if I do 9x equals 117, I can divide both sides by 9. And I'm going to get that x is equal to 117 divided by 9 is going to be 13. So x equals 13 is my solution. All right, let's take a look at problem number 10 now. So we're going to have this 9x plus 8 times the quantity 1 minus 2x. This is equal to negative 5 times the quantity x minus 4. All right, on the left, I have my 9x, and then plus 8 times 1 would be 8, and then minus 8 times 2x would be 16x. Now, I can do 9x minus 16x. That's going to give me negative 7x. So let's put negative 7x here like this, and then plus 8. On the right, I have negative 5 times x, which is just negative 5x. And then negative 5 times negative 4, let's say that's plus 20. So let's copy that down here. So negative 5x plus 20. On the left and on the right, everything is as simple as I can make it. So basically, I'm just going to move all the variable terms to the left. So let's add 5x to both sides of the equation. And then I'm going to move all my constants to the right. So let's subtract 8 from both sides of the equation. Let me go ahead and cancel this guy and also this guy. So we see that negative 7x plus 5x would be negative 2x. And this equals 20 minus 8 would be 12. As a final step, let's divide both sides of the equation by negative 2. Again, the coefficient of x. Again, this is going to cancel and just give me x, or you could say 1x if you wanted to be more specific. Scroll down here a little bit, so I'll just put x over here. And then this guy, 12 would be divided by negative 2, and 12 divided by negative 2 is negative 6. So the solution here is x equals negative 6. All right, let's take a look at our practice test. We're told to solve each equation. And let's take a look at problem number 1. So this guy has negative 2/3 x plus 11 over 6. This is set equal to x plus 91 over 6. Now, if you have fractions in your equation, you can clear them or you cannot clear them. You'll get the same answer either way. A lot of times we'll clear them with fractions because it does make it a little bit easier to work with them. So if you want to do that, basically what you would do is look at all your denominators. So you have a 3, a 6, and a 6. And you want to find what is the least common denominator. And you do that by finding the least common multiple, or your LCM, of those denominators. So if I think about 3, it's a prime number. If I think about 6, it's 2 times 3. And 6 is again 2 times 3. So the least common multiple there would be 6. So I would just multiply both sides of the equation by that number 6. This is the least common multiple of, again, the 3 and the 6, or you could say the least common denominator that you can have here. So I'll go ahead and say this is 6 being multiplied by this negative 2/3 x plus 11 6. I'm using parentheses here because the 6 is going to basically multiply by each. And this is equal to, let's go ahead and put x plus 91 over 6 like this. And I'll put times 6 like this. And basically, this is going to, again, get distributed to each guy inside. So everything is being multiplied by 6. Remember, this is legal because of our multiplication property of equality. We can always multiply both sides of an equation by the same non-zero number and not change the solution set. Okay, so distributing this in, let me show this the long way. So 6 times negative 2/3 x like this, plus 6 times 11 6 is equal to, you'll have 6 times x, which is just 6x, plus 91 over 6 times 6. And all this is doing is just clearing all the denominators for you. So 6 divided by 3 would be 2. 2 times negative 2 is negative 4. So you get negative 4x plus 6 divided by 6 is 1. This is 11. This equals, here you have 6x. And then plus 6 divided by 6 is 1. 91 would just be there. Okay. So now you have this into a format that you're used to working with. And from here, it's really easy to solve the equation, move all your variable terms to one side, all the numbers, or you would say the constants, to the other. Again, personally, I like my variable to be on the left. If you like yours on the right, you can do that as well. But I'm going to subtract 6x away from both sides of the equation, and I'm going to subtract 11 away from both sides of the equation. So let me show this is canceling and this is canceling. And essentially what you're going to have here is negative 4x minus 6x would be negative 10x. And this will be equal to 91 minus 11 is going to be positive 80. And to finish this off, remember, I want to isolate x. That's how I solve an equation. So to do that, all I really need to do here is divide both sides of the equation by negative 10. This is my coefficient of x, or what is multiplying x. So if I divide by negative 10 there, this cancels with this and gives me a 1. So I have 1x, or just x. And this will be equal to, do the same thing over here, divide by negative 10. 80 divided by negative 10 would be negative 8. So this is my solution. Again, you know how to check it at this point. You take this negative 8, you plug it in for each occurrence of x in the original equation, and make sure the left side equals the right side. Okay, let's look at another example. So here is example 2, and we'll pick up the pace a little bit here. We have 1/4 x plus 15/4 is equal to 15/4 plus 9/7 x. Okay, what's the LCD? What is the least common denominator here? Again, look at all your denominators. You have a 4, a 4, a 4, and a 7. So what is the least common multiple of 4 and 7? That's going to be 28, right? Because 4 is 2 times 2. 2 is a prime number. 7 is a prime number. So really it would be 2 times 2 times 7, which is 28. So I would multiply both sides of the equation by 28. And again, you could put this out in front of some parentheses if you want, but you end up just distributing it in. So I'm just going to multiply each guy here by 28. I think that's a little bit faster. So 28 times 1/4 x plus 28 times 15/4 is equal to 28 times 15/4, and then plus 28 times 9/7 x like this. All right, so 28 divided by 4 is 7. So let's cancel this with this and put a 7. And then again, 28 divided by 4 is 7. And then 28 divided by 4 is 7. And then 28 divided by 7 is 4. Here we would just have 7x and then plus, what is 7 times 15? If you punch that into a calculator, you get 105. This equals, again, you'd have 7 times 15, so that's 105. And then we're going to go plus 4 times 9 is 36, and then times x, so this would be 36x. All right, now when you have the same thing on each side of an equation, you can get rid of it, because I could subtract 105 away from each side, but the quicker way is just to cancel it away. Okay, so that's going to be gone. Now, we can see at this point that the solution will be that x is 0, or hopefully you can see that. If you can't, it's not that big of a deal. Let's just solve this completely. Let's subtract 36x away from each side of the equation. And let me go ahead and cancel this. And so the right side here is just 0. On the left side, if you do 7x minus 36x, that's going to give you negative 29x. And of course, we would divide both sides by negative 29. And as I said a moment ago, our solution here is going to be that x is equal to 0. So this would be our solution. Okay, let's look at another one. So here we have negative 81 over 14 plus 1 over 6x is equal to 8 over 7x minus 23 over 6. So what is my LCD? Let's think about these denominators. You've got 14, 6, 7, and 6. Okay, so what is 14? It's 7 times 2. 6 is 2 times 3. 7 is prime. And 6 is 2 times 3. So if I'm building the LCM, that would be what? Every prime factor goes in, but again, you use the largest number of repeats between the factorizations. So I have a 7 here and a 7 here, so 1 goes in. I have a 2 here, a 2 here, and a 2 here, so 1 goes in. I have a 3 here and a 3 here, so 1 goes in. So 7 times 2 is 14. 14 times 3 is 42. So that's what I want to use. So I'm just going to multiply both sides of the equation by 42. And let's just go ahead and do that. So we're going to have 42 times negative 81 over 14, plus you're going to have 42 times 1/6x equals 8/7 x times 42. And I probably should reverse that. So let's go ahead and put the 42 out in front like this, times 8/7 x. And then minus, you're going to have 23 over 6 times 42. Okay, let's just go through and do some canceling real quick. 42 divided by 14 is 3. 42 divided by 6 is 7. 42 divided by 7 is 6. And then 42 divided by 6 is 7. Okay, so 3 times negative 81 is negative 243. And then plus, you'd have 7x, and this equals 6 times 8 is 48, so 48x. And then minus, what is 7 times 23? Punch that into your calculator, you get 161. Okay, let's come down here a little bit, and let's see what we have. So I'm going to subtract 48x away from each side of the equation. And let me make that a little bit better. And let's go ahead and show this as canceling. And let's add 243 to both sides of the equation. And let's go ahead and show that as canceling. So what is 7x minus 48x? That's going to be negative 41x. This is equal to, what is negative 161 plus 243? Well, that's going to give me 82. Okay, as a final step, remember, I want to get x by itself. So let's divide both sides by negative 41, that coefficient of x. And essentially, this cancels. You get x is equal to 82 divided by negative 41 would be negative 2. So this is my solution, x equals negative 2. All right, let's take a look at problem number 4. So we have 35 over 12x plus 1 plus 1/3 x is equal to 1/2 x minus 1/4. All right, so my LCM of 12, 3, 2, and 4 is going to be 12. Okay, so that's the least common denominator that I can form here. And so basically, I would multiply everything by 12. Again, once you get faster at this, you can just do it mentally. So let's just try to do that for this one. So I know if I multiply this by 12, the 12 in the denominator is going to cancel, right? So I would just be left with 35x and then plus. If I multiply this by 12, I would get 12, then plus. If I multiply 1/3 by 12, 12 divided by 3 is 4, and then 4 times 1 is 4, so this would be 4x. And this equals 1/2 times 12 would be 6, and then times x, and then minus 1/4 times 12. 12 divided by 4 is 3. So this would be 3 like this. Okay, again, if that's a little too fast for you, you can always pause the video and you can show it as being multiplied by each guy here and then go through the cancellations and the simplifications from there. Okay, so what I want to do now is combine any like terms. 35x plus 4x would give me 39x, and then plus 12, and this equals 6x minus 3. So let's go ahead and subtract 12 away from each side of the equation. Let's come down here and see what we're looking at. So I'm going to go ahead and cancel this. And also, I'm going to subtract 6x away from each side of the equation. So let's go ahead and cancel this guy right here as well. Okay, so 39x minus 6x is going to be positive 33x. And this equals, if I do negative 3 minus 12, that's going to be negative 15. So to get my final answer here, again, I want to divide both sides by 33, the coefficient of x, so that x will be by itself. And let's slide down here. So we know this cancels. You'll get x is equal to negative 15 over 33. Well, we know this is negative, and this is not going to be an integer or something like that. So we really just want to think about simplifying the fraction 15, which is 5 times 3, over 33, which is 11 times 3. So let's just go ahead and cancel this 3 with this 3. So I'm going to report my answer as negative 5/11. So x is equal to negative 5/11, like this. All right, let's look at problem number 5. So here we have 207 over 25 minus 7/2 x is equal to negative 9/5 times the quantity 3/2 x minus 19/5. All right, so the idea here is that if you have parentheses involved, you need to remove those first before you try to find your LCD. So let's just go ahead and copy this left side to 207 over 25 minus 7/2 x is equal to, I'm going to distribute this in. So basically, I'm just going to multiply. I know this is going to be negative. 9 times 3 is 27, and 5 times 2 is 10. And then I'll have x that comes along for the ride. Negative times negative is positive. And then basically, you would have 9 times 19, which is 171, and then 5 times 5, which is 25. Okay, so now that I've removed the parentheses there, I can go through and clear my fractions. If you look at the denominators, I've got 25, I've got 2, 10, and 25. So again, now let's write this as 5 times 5. 2 is a prime number, 10 is 5 times 2, and 25 again is 5 times 5. So if I'm building the LCM, again, 5 is going to go in there. It occurs twice here, once here, and twice here. So the largest number of repeats between these factorizations is 2. So I'm going to put 5 squared or 25 in. Now when I look at the only other factor that occurs, it's 2. It occurs once here and once here. So I'm just going to put 1 in there. So this is going to be 25 times 2 or 50 that I need. So let's go ahead and say that we're going to multiply both sides by 50. So 50 times 207 over 25. You can think about 50 divided by 25 is 2. 2 times 207 is going to be 414. Then minus, if you do 50 divided by 2, that's 25. 25 times 7 is 175. And then don't forget about that x there that's going to come along for the ride. And this equals, we're going to have negative. 50 divided by 10 is 5. 27 times 5 is going to be 135. And then again, the x is going to come along for the ride there. And then lastly, if I do 50 divided by 25, that's 2. 2 times 171 would be 342. Okay, so now I'm just going to do my normal procedure. I'm going to add 135x to both sides of the equation. And then I'm going to subtract 414 away from each side of the equation. Let me see what we have here. So this guy is going to cancel. This guy is going to cancel. If I do negative 175x plus 135x, that's going to give me negative 40x. And this is equal to, if I do 342 minus 414, that's going to give me negative 72. Okay, so let's slide down here a little bit and see what we have. So I'm going to divide both sides by negative 40. And essentially I'm going to have x is equal to, negative over negative is positive. Let me go ahead and write 72 as 8 times 9. And let me write 40 as 8 times 5. And I think it's clear that this is going to cancel with this, and you'll basically have x is equal to 9/5. This will be your solution. Okay, let's look at problem number 6. Now we're working with decimals. So here's my personal opinion on this. Although I'm going to clear the decimals, I think it's a complete waste of time in practice because for most of the problems, you're going to be using a calculator. Calculators usually don't make things faster when you work with fractions, but they make things tremendously faster when you work with decimals, right? So this is just like working with whole numbers for me. So I think clearing the decimals is a complete waste of time. But again, it's taught in every single algebra class, so we need to cover it. So basically for problem 6, you have 5.4x minus 8.43 is equal to 6.1x and then minus 6.4. So how do I clear this equation of decimals? I look at the number of decimal places that I have in each term here. So this would be 1, this would be 2, this would be 1, and this would be 1. So basically you go with the highest number of decimal places. That's what you need to clear, right? And to clear that, you go 10 to the power of whatever that highest number of decimal places is. In this case, it's 2, so 10 squared would be 100. You multiply both sides by 100, you'll clear all the decimals. So let's do this like this the first time. So 5.4x like this, minus 8.43. This equals, let's put 100 out in front, and then 6.1x like this, minus 6.4. Okay, so this is going to multiply by each guy inside. And again, when you multiply by 100, you're moving your decimal point 2 places to the right? So you just look at how many zeros you have there in that power of 10. That's how many places to the right you're moving. If it was just 10, you'd move 1 place to the right. If it was 1,000, you have 3 zeros, you'd move 3 places to the right, so on and so forth. So for this guy, I'm going to move the decimal point 2 places to the right. So that's 5, 4, 0, right? So this is going to go 1, 2 places to the right, then x, so 540x, then minus, this would go 1, 2 places to the right, so 843. This equals, this would be 610x, and then minus, this would be 640. Once we have the decimals cleared, again, we can just use our normal procedure. So I'm going to go ahead and subtract 610x away from each side of the equation. And let's go ahead and cancel this. And I'm going to also add 843 to both sides of the equation. So let's go ahead and cancel this guy right here. So 540x minus 610x, this would give me negative 70x. And this equals 843 minus 640 is going to be 203. And all I want to do is just divide both sides by negative 70. So divide here by negative 70. So I'm going to cancel this with this, and I'll put x is equal to, let's just give our answer as a decimal. So I'm going to put a negative here, and I'm going to divide 203 by 70 in my calculator, and that would give me 2.9. So I'm going to say that x equals negative 2.9, and I'll put that as my solution. In some cases, you may want to report your answer as a fraction. It's really up to you and your teacher in terms of how you report it. The number is the same whether it's a fraction or a decimal in terms of its value. So x equals negative 2.9 is going to be our solution. Okay, let's look at problem number 7. So a very similar setup. We have 9.06 plus 6x equals 3.4x minus 2.9. So the highest number of decimal places, you see this one has 2 here, none here, 1 here, 1 here. So again, I need to multiply everything by 100 and move the decimal point 2 places to the right. So this would be 906 plus, this would be 600x. This equals, I would have 340x and then minus 290. So let's go ahead and subtract 340x away from each side of the equation. And let's also subtract 906 away from each side of the equation. Let me make that better. And I think this 3 could be more legible here, so let's do that. And let's go ahead and cancel this, and let's cancel this. So 600x minus 340x would be 260x, and this equals negative 290 minus 906. Let me make that more legible so everybody can see what that is. So this would be negative 1,196. And again, all I want to do to solve this is divide both sides by 260. So divide this side by 260. And again, because we're working with decimals, let me just give my answer as a decimal. So x equals, I know this is negative. Let's punch this into our calculator. So I end up with 4.6. So x here will equal negative 4.6. That'll be my solution. Let's look at problem number 8. So we have negative 5.5x plus 6.1x equals negative 3.7x minus 13.76. So you'll see that you have one decimal place, 1, 1, and 2. So again, I'm just multiplying everything by 100. So this is negative 550x plus 610x is equal to negative 370x minus 1,376. So in this case, I can combine like terms on the left. And so I'm going to go ahead and say that I have negative 550x plus 610x, which is going to give me positive 60x. So this equals negative 370x minus 1,376. Let me go ahead and add 370x. I'm not making these threes very well today, so 300, still can't do it. So 370x to both sides of the equation. And let me show that this is going to cancel. If you punch this into your calculator, you're going to get 430x. We'll say this is equal to negative 1,376. Again, because we're working with decimals, let's just go through and give a decimal answer. I'm going to divide both sides by 430 so that I can isolate x, and I'll get x is equal to negative. Let's punch this into our calculator. I get 3.2. So my answer here is x equals negative 3.2. So that's my solution. Let's look at problem number 9. So we have 7.68 minus 3.3x equals negative 4.9x minus 4.8x. So let's go ahead and again multiply everything by 100. So this would be 768 minus 330x is equal to negative 490x minus 480x. We can combine like terms here. This would be negative 970x. So negative 970x like that. And then again, I just want to add this to both sides of the equation. So add this over here. And I'm going to subtract 768 away from each side of the equation. So this guy is going to cancel. This guy is going to cancel. If I do negative 330x plus 970x, that would be 640x. And this is equal to, again, over here I have negative 768. Let's divide both sides by 640 so we can isolate x. And so we'll have x is equal to negative, again, punch this into your calculator, 768 divided by 640, and you get 1.2. So x here equals negative 1.2. That's going to be my solution. Okay, let's look at problem number 10, the last problem. So we have negative x plus 15.6 is equal to negative 4.4 times the quantity x minus 3.7. So just like with fractions, if you have parentheses, go ahead and clear them first before you try to clear any decimals. But again, if I'm working this problem in the real world, I don't clear decimals, so this is just a matter of personal preference. So I'm going to put negative x plus 15.6 is equal to negative 4.4x. And then negative times negative is positive. I would really have to do this in a calculator. I mean, you could do it by hand, but it would take a long time, right? You'd have to do 44 times 37 and then move the decimal point in the answer 2 places to the left. But I'm not going to do that. I'm just going to use my calculator. And that gives me 16.28. What we need to do is multiply everything by 100 because I have 2 decimal places here. All right, so let's go ahead and do that real quick. I'll put negative. This is a 1. If I multiply by 100, it's negative 100x. And then plus, this would be 1,560, right? Because this is going 2 places to the right. And then this equals negative 440 times x, then plus 1,628. All right, let me slide down here. And this one's pretty easy to solve, just like all of them. I'm going to add 440x to both sides of the equation. And let's go ahead and cancel this out. And then I'm going to subtract 1,560 from both sides of the equation. And let's go ahead and cancel this out. So negative 100x plus 440x would be positive 340x. And this equals, over here, 1,628 minus 1,560 is going to be positive 68. Let me divide both sides by 340. Let me make this better. Again, I can't make 3's today, so 340 over here. So x is going to be equal to, let's punch this into our calculator, and I get 0.2. So let's just write 0.2 there. So x equals 0.2. That's going to be our solution. All right, so we want to convert each repeating decimal into a fraction. And we're just going to look at 0.93, where the 3 repeats forever. So hopefully you watched the lesson and the practice set video. Essentially, all we're going to do here is we're going to use a variable, and we're going to assign a variable to equal this. So I'm going to say something like x is equal to 0.93, where the 3 repeats forever. So I can also put this as a bunch of 3's here. And then when I decide to stop, I can just put the 3 dots or the ellipsis to show that this 3 will continue forever. Now the next thing I want to do is I want to multiply both sides of the equation by 10 raised to the power of n, where n is the number of digits in the repeating series. Here I just have one digit that's going to repeat forever, so I just multiply both sides of the equation by 10. So I would have 10x is equal to, this would simply move one place to the right, so 9.333. Put as many 3's as I want, because 3 continues forever, and then put your 3 dots. Now the next step is to just subtract this value right here away from each side of the equation. So on the right side, I'm going to subtract 0.9 and then all the 3's. And what's going to happen is this part right here is going to cancel out. And I'll just have the 3 minus 9. I got to borrow for that. So let's make this 8 and make this 13. 13 minus 9 is 4. And I had bring down the decimal point and then bring down the 8. On this side, if I subtract this value away directly, I'm going to end up with a repeating decimal still. So to fix that, I'm just going to subtract away x. Remember, x is equal to this, so I'm still subtracting away the same thing from each side of the equation, so I'm not doing anything illegal. 10x minus x is 9x. And now all I want to do, let me just scroll down a little bit, get a little room. I want to move this one place to the right so I don't have any decimals involved. And I can do that by multiplying both sides of the equation by 10. So I multiply over here by 10, I have 90x. If I multiply over here by 10, again, I move this one place to the right, and I have 84. Then as a final step, I'll divide each side of the equation by 90. And I'll have x is equal to, we have 84 over 90, which would reduce to, 84 is divisible by 6, it would be 14. 90 is divisible by 6, it would be 15. So x is equal to 14/15. Now what I can do, let me erase all this. I can just replace this x here with 14/15. And so this is equal to 0.9, where the 3 after the 9 repeats forever and ever and ever. And again, you can punch this up on your calculator, and you will verify that this answer is correct. Remember, your calculator is not going to be able to display an infinite number of 3's. So what's going to happen is at some point it's just going to cut itself off, or it's going to round when you're checking these. And for this part, we're going to look at 1.79, where the 7 and the 9 repeat forever. So again, we want to set this equal to a variable. So let's just choose z. So z equals 1.79, where the 7 and the 9 repeat forever. And then I want to multiply both sides of the equation by 10 raised to the nth power, where n just represents the number of digits in the repeating series. So in this case, I have 2 digits there. So I would have 10 squared, or 100. So if I multiplied 100 times z, I'd have 100z. Then this is equal to, if I multiply 100 times 1.79, where the 7 and the 9 repeat forever, what's going to happen is this is going to move 2 places to the right. So I'd have 179 point, remember that 7, 9 repeats forever. So I'm going to have 7, 9, I can write 7, 9, 7, 9, 7, 9 with 3 dots, or I can just put the bar over the 7 and the 9. Doesn't matter, either way you want to do it. Now that we have this, what I want to do is I want to subtract this original value here away from each side of the equation. So on this side, I'd subtract away 1.79, again with the bar over the 7 and the 9. Over here, I don't want to do that because I'd still have a repeating decimal. So since z is equal to that, z is the same value as that, I can just subtract away z. 100z minus z is 99z. And over here, we know that this part would cancel itself, and I'd be left with 179 minus 1, which is 178. So now all I need to do is divide both sides of the equation by 99. Scroll down a little bit. So this would cancel with this. I'd have z is equal to, we have 178 over 99. So this would factor into 2 times 89. This would factor into 9, or 3 times 3 times 11. They don't share any common factors other than 1. So this is going to be the best we can do. We're going to put z is equal to 178 over 99. Let's just copy this real quick. And let me go back up to the top. And again, if z is equal to this and z is equal to this, we're saying that this value here, 178 over 99, is the same or is equal to 1.79, where the 7 and the 9 repeat forever. And again, check it on your calculator and you verify you have the correct solution. And what we're looking at here is 0.05, then 437, where the 4, the 3, and the 7, those digits are going to repeat forever and ever and ever. So the first thing we want to do here is just set this value equal to a variable. So let's just say y is equal to 0.05437, again, where the 437 repeats forever. The next thing we want to do is multiply both sides of the equation by 10 raised to the nth power, again, where n is the number of digits in the repeating series. So here we have 1, 2, 3. So this would be 10 to the third power, or 1 followed by 3 zeros, 1,000. So if I multiply this side by 1,000, I have 1,000y. If I multiply this side by 1,000, my decimal point would move 1, 2, 3 places to the right. So I would have 54.37, and then I'd have the 437 that repeats forever. So let me write 437, and that's going to repeat forever. And so now what I want to do is I want to subtract this original value that I started with away from each side of the equation. So over here I'm going to subtract away 0.05437. And again, the 4, the 3, and the 7 are going to repeat forever. Over here I'm not going to do that exactly. Remember, y is equal to that, so y is the same as that. So I'm just going to subtract away y. That's going to keep me from having a repeating decimal anymore. So now what's going to happen is this part's going to cancel out, right? That's gone. 7 minus 5 is 2. 3 minus 0 is 3. I've got my decimal point. Bring down the 4, bring down the 5. And this equals 1,000y minus y is 999y. If I want to clear the decimals from this equation, I can just move this 2 places to the right by multiplying both sides of the equation by 100. So this would end up being 99,900y is equal to 5,432. As a final step, I will divide each side of the equation by 99,900. And I will get that y is equal to 5,432 over 99,900. They're each divisible by 2 at minimum. And it looks like they're actually each divisible by 4. So if I divide this by 4, I would get 1,358. If I divide this by 4, I would get 24,975. So let me copy this real quick. We're going to go back up here. And since y is equal to this and y is equal to this, I can say that 1,358 over 24,975 is equal to, or is the same as, 0.05437, where the 4, the 3, and the 7 are going to repeat forever. And again, as I've told you in every video, you can check this on a calculator. Go ahead and do this division on a calculator, and you'll verify that you have the correct answer. And we're going to take a look at 16.29153, where the 9, the 1, the 5, and the 3 are going to repeat forever and ever and ever. So what I'm going to do here is I'm going to set this value equal to a variable. Let's just say x is equal to 16.29153. Again, where there's a bar over the 9, the 1, the 5, and the 3 to show that those digits repeat forever. All right, the next thing I want to do is I want to multiply both sides of this equation by 10 to the nth power, where n represents the number of digits in the repeating series. So here we have 1, 2, 3, 4. So this would be 10 to the 4th power, which is a 1 followed by 1, 2, 3, 4 zeros, or 10,000. So if I multiply both sides of the equation by 10,000, I will have 10,000x is equal to, if I multiply this by 10,000, I'm going to move this decimal point 1, 2, 3, 4 places to the right. So I would have a 162,915.3. And then remember, this continues forever. So I would have a 9153. And I can put my bar on the top of these digits. And so I'd have 162,915.3 and then 9153 with the bar over it. And so now I want to subtract this right here away from each side of the equation. So I'm going to subtract this away over here. So we know that this part right here is going to cancel itself out. We know 3 minus 2 is 1. We have our decimal point. Borrow here. I'd have 15 minus 6. That's going to be 9. Borrow here. I'd have 10 minus 1. That's going to be 9. Then I'd have an 8, a 2, a 6, and a 1. So I'd have 162,899.1. On this side, I'm not going to subtract this value. I'm going to subtract x. Remember, that's legal because x is equal to this, and I'm still subtracting the same value away from each side of the equation. So this is 9,999x now. And let's scroll down a little bit, give ourselves some room. And I want to clear this decimal here. So let's multiply both sides of the equation by 10. That'll move this over one place to the right. And that will give me 1,628,991. Over here, if I multiply by 10, I'd have 99,990x. Now, as a final step here, I'm going to divide both sides of the equation by 99,990. And what's that going to give me? Well, this is going to cancel with this and give me x. Over here, I can cancel a common factor of 9 between the two. 1,628,991 divided by 9 is 180,999. And then if I divide 99,990 by 9, I will get 11,110. So let's copy this real quick. And since x is equal to this and x is equal to this, I can just substitute in here and say 180,999 over 11,110 is equal to, or is the same as, 16.2 and then 9153, where the 9, the 1, the 5, and the 3 are going to repeat forever. And again, check this on a calculator. Take 180,999 and divide it by 11,110, and you'll see that you have the correct answer. Now remember, your calculator can't possibly display an infinite number of digits, so it's going to either truncate or it's going to round when you're working this type of problem. So we're going to take a look at 0.35, and then we have 18367, where the 18367 repeats forever. So we want to start out by just setting this equal to a variable. Let's just use y. So let's say y is equal to 0.351837. Again, with a bar over the 18367 to indicate that repeats forever. Then the next thing we want to do is multiply both sides of the equation by 10 raised to the nth power, where n is the number of digits in the repeating pattern. So we have 1, 2, 3, 4, 5. So it would be 10 to the 5th power. So that's a 1 followed by 1, 2, 3, 4, 5 zeros, or 100,000. On the left side, I would just have 100,000 y. On the right side, I would move this decimal point 1, 2, 3, 4, 5 places to the right. And so I would have 35183, then 0.67, and then I have the 18367. So I'm going to put a bar over the 18367, again, to indicate that repeats forever. So 35,183.67, and then again, you have your 18367 that repeats forever. So now what I want to do is I want to subtract this original value away from each side of the equation. So I'm going to subtract 0.3518367 with the bar over the 18367. And we should know at this point that this part's going to cancel itself. I'll have 7 minus 5, that's 2. 6 minus 3 is 3. I've got my decimal points. And I can just bring down the rest. The 3, the 8, the 1, the 5, and the 3. Now over here, to make this legal, I've got to subtract the same value away. But I don't want to subtract this away directly. Remember, y is equal to this, so y is the same as that. So I can just subtract away y. And what that's going to do is that's going to give me 99,999y. And I want to get rid of this decimal here. So to do that, I'm going to multiply both sides of the equation by 100. So that would give me a 9, a 9, a 9, a 9, and a 9. Put 2 zeros at the end. And you'll have 9,999,900. Then y is equal to, this would go 2 places to the right. So I would have 3,518,332. I can divide each side of the equation now by 9,999,900. So this would cancel, and I'll have y is equal to, I have 3,518,332 over 9,999,900. Each of those is divisible by 4. If I divide this by 4, I would get 879,583. If I divide this by 4, I would get 2,499,975. Let me slide this down a little bit. So again, if y is equal to this and y is equal to this, I can substitute in here and say this is 879,583 over 2,499,975. This is equal to 0.35 and then 18367, where there's a bar over those digits to say that repeats forever. And again, you can verify this by using a calculator to do the division. Just remember that a calculator is going to not be able to display an infinite number of digits, so it's either going to truncate or it's going to round, depending on how your calculator is going to function. All right, let's take a look at our practice test. We're told here to solve each equation and state the equation type. So let's come down here. Let's look at equation number 1. So we have this negative 4 times the quantity x minus 6 plus 11 times the quantity x minus 6. This is set equal to negative 2x plus 12x. Okay, so on the left, I'm just going to use my distributive property to clean things up. Negative 4 times x is negative 4x. And then you'll have negative 4 times negative 6. Let's put plus 24 like this. Then we'll have plus 11 times x is 11x, so plus 11x. And then basically minus 11 times 6 is 66. And let's set this equal to, over here on the right, let's just copy this. So negative 2x, then plus 12x like this. Okay, so on the left, I can clean up because I have negative 4x plus 11x. That's going to give me positive 7x. And then 24 minus 66 is going to be negative 42. So let's put minus 42 like this. And this equals, on the right, I can combine like terms. Negative 2x plus 12x is going to be positive 10x. And let's go ahead and say that we're going to subtract 10x away from each side of the equation like this. And I'm going to add 42 to both sides of the equation like this. And let's go ahead and cancel this guy here and this guy here. And so 7x minus 10x is going to be negative 3x. And this is equal to, let's go ahead and say this is 42 over here. And then to finish this off, I want to isolate x. Let's divide both sides by negative 3. And let's go ahead and say that x is equal to negative 14, right? 42 divided by negative 3 is negative 14. The idea here is to determine if the equation is conditional, an identity, or a contradiction. So because this guy, we're solving a linear equation in one variable, because this guy has one single solution here and one single solution only, we can say that this is a conditional equation. It's true under the condition that x equals negative 14. It's false for any other value of that variable, right? If I said x was negative 13, it wouldn't work, right? It would not solve the equation. So this is a conditional equation. Conditional, like this. Let's look at problem number 2. So we have negative 2 times the quantity 6x plus 6 plus 11 This is equal to the negative of the quantity 1 plus 12x. All right, let me slide down here. Again, I'm just going to clean up with the distributive property. Negative 2 times 6x is negative 12x. The negative 2 times 6 would be minus 12. And then we have plus 11 here. This equals over here. If I have a negative in front of some parentheses, I'm just going to change the sign of everything inside. So it's like multiplying everything by negative 1. So this would be negative 1 and then minus 12x. Again, just changing the sign of everything and dropping the parentheses. All right, so what do we see? On the left-hand side, I can combine like terms. Negative 12 plus 11 is going to be negative 1. So I have negative 12x minus 1. And over here, I could actually rearrange this to have negative 12x minus 1 as well. So if you see the same thing on each side of the equation, you know that no matter what you plug in for x, it's always going to be true, right? Because the same thing is being done. Here, when I plug something in for x, I multiply by negative 12, and then I subtract away 1. Same thing happens over here. So it doesn't matter what the value of x is that I choose. So this is called an identity. And you could also go through the full process. So you could add 12x to both sides of the equation. So this is gone over here and here. You could add 1 to both sides of the equation. So it's gone here and here. So basically you get 0 equals 0, okay, which is a true statement. So this is an identity. It's true no matter what you replace x with. So we'll say this is an identity. Let's take a question 3. So we have negative 12x plus 8x is equal to negative 8 times the quantity x minus 5, and then minus 10 times the quantity 1 minus x. All right, over here, I can just make this negative 4x if I combine like terms. This equals negative 8 times x is negative 8x. Negative 8 times negative 5 is plus 40. And then negative 10 times 1 is minus 10. And then negative 10 times negative x is plus 10x. If I combine like terms here, negative 8x plus 10x is going to be positive 2x. So let's just do this in line. I'll just say this is 2x like this. And then 40 minus 10 is going to be 30. So let's put plus 30 like that. I'm just going to go ahead and subtract 2x away from each side of the equation. So like this. And this will cancel. And I'll have negative 6x is equal to positive 30. Divide both sides by negative 6. And I'm going to have x is equal to negative 5. So this guy right here is conditional, right? Remember, it's true under the condition that x equals negative 5. It's false otherwise. So this, let me scroll down just a little bit more. This is conditional. Okay, so we have problem number 4. So we have 3x plus 11 times the quantity x minus 8 is equal to 2 times the quantity x minus 2. Let me slide down here. So this is 3x plus 11x, and then minus 88 is equal to 2x, and then minus 4. So just distributing things to clean up. On the left, 3x plus 11x is 14x, and then minus 88, and this equals 2x minus 4. Let's go ahead and subtract 2x away from each side of the equation. Let's also go ahead and add 88 to both sides of the equation. So we'll see that this is going to cancel and this is going to cancel. So 14x minus 2x is 12x. And this equals, if I do 88 minus 4 or negative 4 plus 88, however you want to do that, you're going to get 84. So divide both sides by 12 so you can isolate x. And you get x is equal to, let me slide down here, 84 divided by 12 is going to give you 7. So x equals 7 is your solution. So again, this is conditional. This is conditional. All right, let's look at problem number 5. So we have negative 8 minus 5 times the quantity x plus 9. This is equal to negative 3 times the quantity x minus 8, and then we're subtracting away 2x. Let me write negative 8, and then negative 5 times x would be minus 5x. Negative 5 times 9 would be minus 45. This equals, over here, negative 3 times x is negative 3x. And then negative 3 times negative 8 is positive 24. And then you have minus 2x. So on the left, negative 8 minus 45 would be negative 53. So basically you have negative 5x minus 53 like this. Let me rewrite this so it's a little bit cleaner. On the right, you have negative 3x and negative 2x. So that's negative 5x also, and then plus 24. So let's pause for a minute and think about this. Is there anything I can possibly plug in for x that would give me a true statement? No, because the same value would be here as here, no matter what I plug in for x. And basically, I'm subtracting away 53 from it here, and I'm adding 24 to it there. How could they ever be equal? They can't be, right? Another way to think about this, I could simply add 5x to both sides of the equation here. This would cancel and this would cancel, and I'm left with negative 53 is equal to 24, right? So this is a false statement. So if your variable drops out and you're just left with this false statement, you can say that you don't have a solution. So you could write no solution. like this, right? A lot of people put the symbol for the null or empty set, so you could do that if you wanted to. But the main idea here is to identify the type of equation, and this type of equation is called a contradiction. So a contradiction. Okay, let's look at number 6. So we'll come down here. We have 7 times 20x plus 1 is equal to negative 1 plus 7 times 20x minus 2. So we're going to get 7x plus 7 is equal to negative 1 plus you're going to get 7x minus 14. So again, you can already see you're going to have a problem because you have 7x over here and 7x over here. And basically, if you combine like terms over here, let's just put 7x plus 7 is equal to negative 1 minus 14 is going to be negative 15. So this is 7x minus 15. This you can just go ahead and cancel, right? If I subtract 7x away from each side, it's gone. You're going to be left with 7 equals negative 15. So 7 equals negative 15, which is false. So again, you have a situation where you have no solution, right? So you could write no solution. A lot of people just, again, write this symbol for the null or empty set. And again, the type of equation here, we're dealing with a contradiction. So this is a contradiction. Contradiction. Okay, let's look at problem number 7. So it looks like we have a lot of work to do on cleaning this up, but we have the negative of 3x plus 1/3, so this quantity, minus 2/3 times the quantity 5/2 x plus 3/2. This equals 4/3 x plus 1/3 x. So I would apply this negative first. So this would be negative 3x and then minus 1/3. Just applying that negative to each term inside. Then for this guy, you have negative 2/3 times 5/2. The 2's would cancel and you would have basically negative 5/3 x like this. Then if you're dealing with negative 2/3 times 3/2, well, this is basically going to be negative 1. Right? So we know it's negative times positive, that's negative, and then 2/3 and 3/2, those guys are reciprocals, so the result is 1. So then this equals 4/3 x plus 1/3 x. So all your fractions have a denominator of 3, so you can just multiply everything by 3 and clear all your denominators. Let's go ahead and do that real quick. So this would be negative 9x minus, this would be 1, then minus 5x, and then minus this would be 3. So I just multiply this by 3, this by 3, this by 3, and this by 3. And this equals, got to do the same thing over here. So this would be 4x, and then plus, this would be 1x or just x. Negative 9x minus 5x would be negative 14x. And then negative 1 minus 3 would be minus 4. And this equals 4x plus x would be 5x. So I'm going to subtract 5x away from each side of the equation and add 4 to both sides of the equation. And again, in terms of what's going to cancel, this is going to be gone and this is going to be gone. Negative 14x minus 5x is going to be negative 19x. And this is going to be equal to positive 4. To finish this up, let's just divide both sides by negative 19, like this. And we really can't simplify that fraction. We're just going to say x is equal to negative 4/19. Now for this guy right here, this tells us we have a conditional equation, right? It's true under the condition that x equals this negative 4/19. So let's go ahead and put this as conditional. All right, let's look at problem number 8. So we have this negative 7/2, and then let's go ahead and distribute this. So negative 1/3 times x would be minus 1/3 x. Then negative times negative is positive. 1/3 times 7/2 would be 7/6. And this equals, let me distribute here as well. So negative 1/3 times x is negative 1/3 x. And then if you do negative 1/3 times 3/2, this is going to be negative. The 3's would cancel and you'd have a half. Okay, so the LCD here would be 6, right? Because you have a denominator of 2, 3, 6, 3, and 2. So just multiply everything by 6. So basically, if I multiply this by 6, 6 divided by 2 is 3. 3 times negative 7 is negative 21. And then minus 6 divided by 3 is 2. 2 times 1 is 2, and then times x, so this is 2x. And then plus 6 divided by 6 is 1, so this is just 7. I can go ahead and do negative 21 plus 7, that's negative 14. So let's make this negative 14 like this. Let's put equals. I'm multiplying this by 6. 6 divided by 3 is 2. So this would be negative 2x like this. And then minus, I'm multiplying this by 6. 6 divided by 2 is 3. So this would be a 3 here. Now, you see there's a problem because you have negative 2x here, negative 2x here. So if you cancel that on each side, you're left with negative 14 is equal to negative 3, which is obviously false. So we can see here again we have no solution. Again, you can write your symbol for the null or empty set. You could write out no solution. Again, whatever your teacher wants. But the idea for this exercise is to note that this is a contradiction. All right, let's look at problem number 9. So we have this negative 2.4 times the quantity 0.6 plus x is equal to, we have this negative 3 times the quantity 0.95 plus 0.8x, and then minus 2.5. Okay, let's see what we're looking at here. I'm just going to clean up using the distributive property first. If you punch this into your calculator, negative 2.4 times 0.6, this is negative 1.44. And then negative times positive is negative, so this would be negative 2.4x. And this equals negative 3 times 0.95 would be negative 2.85. Let me make this better. And let me actually make this x better here. Doesn't look so good. And then we're going to have negative times positive, so that's negative. 3 times 0.8 is 2.4. And then x would come along for the ride. And then you have minus 2.5. So again, you can already see that there's a problem. You have negative 2.4x. You have a negative 2.4x. So without going any further, you see the variable is going to drop out, right? Because it's going to cancel from here and here. And you're going to be left with a false statement, right? So I can say that there's no solution here. So this is a contradiction. Okay, let's look at the last problem. So problem number 10. Let's come down here. We have 0.2 times the quantity x minus 2.1. This equals 1.3 times the quantity 1.1 minus x, and then plus 1.1x. All right, so this first one would be 0.2x, and then minus. You multiply this guy right here, 0.2 times 2.1. That's going to give you 0.42. And this equals, you're going to have 1.3 times 1.1. That's going to give you 1.43. And then minus 1.3 times x is 1.3x. And then plus 1.1x. And if you want to, you can clear all the decimals. Again, I usually don't do this because we work with calculators anyway. But let's just go ahead and do it for the sake of completeness. The largest number of decimal places is 2. So I'm going to multiply everything by 100. So this would be 20x minus, this would be 42, is equal to 143. And then minus 130x. And then plus 110x. So then just combining like terms over here, let me put 143. And then negative 130x plus 110x is going to be negative 20x. So let's put 20x over here and minus 42. Now 20x is not the same as negative 20x. So don't immediately exit the problem there and say you have no solution. Because in this case, I can add 20x to both sides of the equation. And of course, this is going to cancel. And I can add 42 to both sides of the equation. So this guy right here is going to cancel. 20x plus 20x is going to be 40x. And this equals 143 plus 42 is 185. So let me make that a little bit better there. Let me divide both sides by 40. And I'm just going to answer this as a decimal. So I'm just going to say that x is equal to, let's punch this into the calculator, and we're going to get 4.625. So this is my solution here. And more importantly, it tells me that I have a conditional equation, right? The equation is made true by this value and this value only, right? So under this condition. So we'll say this is conditional. All right, let's take a look at our practice test. We're told to solve each equation. And for problem number 1, looks like we have 12 over 6, which of course you could write as 2 if you wanted to, is equal to x over 3. So basically the idea, if you get something that sets up this way, we can cross multiply. So in other words, we can multiply 6 times x. So this would be 6x. And set this equal to, we could do 3 times 12, which would be 36. And of course, if you wanted to, you could solve this by dividing 12 by 6 and getting 2, and then saying 2 equals x over 3. You could solve it that way if you want. It's going to give you the same solution. So let's just go ahead and divide both sides by 6 here. And we'll say that x is equal to 6. Okay, so that would be our solution. Okay, let's look at problem number 2. So here we have 12 over 8x is equal to 3 over 10. So again, I'm just going to cross multiply to set things up. 8x times 3 is 24x. And this equals 10 times 12 would be 120. So all I would do here is just divide both sides by 24. And I would get that x is equal to 120 divided by 24 is going to be 5. So that would be my solution. All right, let's take a question 3. So here we have x minus 2 over 5 is equal to x plus 11 over 4. So again, I'm just going to cross multiply. So 4 times the quantity. So you're multiplying by these two terms here, x minus 2. So make sure you wrap this in parentheses, is equal to 5 times the quantity, 5x plus 11. So the common mistake here is just to multiply 5 by x and then have plus 11, or to multiply 4 by x and then just have minus 2. But the 4 has to multiply by the x and the negative 2. Here the 5 has to multiply by the x and the positive 11. Okay, so let's slide down here and see what we can get. So we're going to have 4x minus 8 is equal to 5x plus 55. And I'm going to subtract 5x away from each side of the equation. Let me make this a little bit cleaner. So subtract 5x away from each side of the equation. Let me add 8 to each side of the equation. And what we're going to see is that this is going to cancel, this is going to cancel. And so 4x minus 5x would give me negative x, or you put negative 1x if you want. And this equals 55 plus 8 is going to be 63. So at this point, you don't have x, you have the negative of x. So you could multiply both sides by negative 1 or divide both sides by negative 1. But either way, you're going to get x is equal to negative 63. So that's going to be my solution. Okay, let's look at problem number 4. So we have 7/12 is equal to x plus 9 over x minus 2. So I'm going to do 7 times the quantity x minus 2. So 7 times the quantity x minus 2. Set this equal to 12 times the quantity x plus 9. So 12 times the quantity x plus 9. So we'd have 7x minus 14 is equal to 12x plus 108. All right, so let me subtract 12x away from each side of the equation. And let's go ahead and add 14 to each side of the equation. And so we're going to see that this will cancel and this will cancel. 7x minus 12x would be negative 5x. And this is equal to 108 plus 14 is going to be 122. Let's slide down here. We know that 122 is not divisible by 5. Forget about the fact that it's negative. So we're going to have an answer that's a fraction, or if you want to use a decimal, that's up to you. I'm going to divide both sides by negative 5. And let's see what we can do. We'll say this is x is equal to, we'll say negative 122 over 5. Again, 5 is a prime number, so you really can't simplify that any further. You could write negative 24.4 if you wanted to, but again, that's just personal preference. So we'll just say this is our solution right there. All right, let's look at problem number 5. You slide down here a little bit. So again, we have 5 over x plus 5 is equal to the negative of 7 over x minus 4. So I'm going to multiply 5 times x minus 4. And again, I'm going to use parentheses there. This equals, I'm going to multiply, let's just go ahead and say this is negative 7 times the quantity x plus 5 here. Because when you have a negative out in front, you have to either apply it to the numerator or the denominator. It can't be both, but it has to be one. So I'm just going to choose to put it on the numerator here. If you choose to put it on the denominator, then this would be positive here, and this would have to be negative out here. Okay, so just keep that in mind. So to clean up here, 5 times x is 5x, and then minus 5 times 4 is 20. This equals negative 7 times x, this is negative 7x, and then negative 7 times 5 is minus 35. Okay, so let's look at this. I want to, let me grab this real quick. So I want to add 7x to both sides of the equation. And let's go ahead and cancel this. I want to add 20 to both sides of the equation. And let's go ahead and cancel this. Okay, let me slide down here. So 5x plus 7x would be 12x. And this equals negative 35 plus 20 is negative 15. Let's go ahead and divide both sides by 12. And that's going to give me that x is equal to, we'll put a negative out in front, 15. Let me go ahead and write this as 5 times 3. And let me write 12 as 4 times 3. And we can see that the 3's are going to cancel away. And so I basically have x is equal to the negative of 5/4. So negative 5/4 there. That would be my solution. Okay, let's look at number 6. Let me grab this, come down here. So we have 6 over x minus 10 equals 2 over x plus 3. Again, just cross multiply. 6 times the quantity x plus 3 is equal to 2 times the quantity x minus 10. So we'd have 6x plus 18 is equal to 2x minus 20. Let me slide down here. Let's go ahead and subtract 2x away from each side of the equation. And so this is going to cancel. Let's subtract 18 away from each side of the equation. So this is going to cancel. 6x minus 2x is 4x. And this equals negative 20 minus 18 would be negative 38. Let's divide both sides by 4 and get that x is equal to, let me slide down here real quick. I'll put the negative of 38 is 19 times 2, and 4 we could put as 2 times 2. So again, you can cancel away this 2 here, this common factor. So let's say x equals negative 19 halves. That'll be our solution. All right, let's look at problem number 7. So let's come down here. we have this x plus 1 over 12 equals x minus 5 over 2. Again, I'm just going to cross multiply. Let's do 2 times the quantity x plus 1 is equal to 12 times the quantity x minus 5. So this becomes 2x plus 2 is equal to 12x minus 60. And then again, I'm just going to subtract 12x away from each side of the equation. And then I'm going to subtract 2 away from each side of the equation. Let me slide down here real quick. This is going to cancel over here. This is going to cancel over here. 2x minus 12x is going to be negative 10x. And this is equal to negative 60 minus 2 is negative 62. So let's go ahead and divide both sides by negative 10. Let me slide down here. And I'll say x is equal to, well, I know it's positive because it's negative over negative. 62 and 10 is going to have a common factor of 2. So let's write this as 31 times 2 over 5 times 2. So we'll go ahead and say that x equals 31/5. So that'll be my solution right here. All right, let's look at problem 8. So we have 7 over x plus 9. This is set equal to the negative of 6 over x minus 4. So remember, if you have this negative out in front, you've got to apply it to either the numerator or the denominator when you're going to cross multiply. If you apply it to the denominator, again, you've got to think about it as the negative of this quantity x minus 4. So let me do it to the denominator there, I think, so that you get some practice with that. So let me just rewrite this and say this is 7 over x plus 9 is equal to, I'm going to put positive 6 over the negative of x minus 4 like this, okay? And you can distribute this and say it's negative x plus 4, but let me just leave it like this for a moment. And let's cross multiply. So 7 times this guy would be, let's just say negative 7 times the quantity x minus 4. And this equals 6 times the quantity x plus 9 like this. So let's put that like that. This would be negative 7x, and then negative times negative is positive. 7 times 4 is 28. And this equals, this would be 6x, and then plus 6 times 9 is 54. Okay, so again, just solving my equation in a normal way. I'm going to subtract 6x away from each side, and I'm going to subtract 28 away from each side. So let's go through here and cancel this. Let's cancel this. And let's see what we have left. Negative 7x minus 6x is going to give me negative 13x. And then I'll set this equal to 54 minus 28 is going to be 26. And we'll divide both sides by negative 13. And what we're going to get is that x is equal to negative 2. So that'll be my solution. All right, let's look at problem number 9. So we have this x minus 2 over x minus 6 is equal to 9 over 6. Again, you can always simplify this if you want. The numerator and denominator, you could cancel a common factor of 3. So you could really say that this problem is x minus 2 over x minus 6. Let me make that 6 better. Is equal to, this would be 3 halves like this. Again, you can work with it this way. It's really just up to you. So I'm going to cross multiply. So I'll do 3 times the quantity x minus 6 is equal to 2 times the quantity x minus 2 like this. So this is going to be what? This is 3x. And then minus 3 times 6 is 18. This equals 2 times x, which is 2x. And then minus 2 times 2, which is 4. Okay, let me slide down here real quick. And let's go ahead and say we're going to subtract 2x away from each side of the equation. And this is going to cancel. And let's add 18 to both sides of the equation. So this is going to cancel. Let me make that x a little bit better. 3x minus 2x is just x. And this equals negative 4 plus 18 is going to be 14. So we get x equals 14 as our solution. Okay, let's look at problem number 10. So we have this x minus 8 over x minus 5. This is equal to negative 4/12. So again, this negative has to be applied to one of these. And also you can simplify this and write this as 1/3 if you wanted to. So really it's up to you. I'm going to put x minus 8 over x minus 5. And I'll go ahead and just make the numerator negative. So I'll put this as negative 1 over positive 3. Okay, so from here, again, I'm just going to cross multiply. Really easy at this point. And I'm going to say negative 1 times the quantity x minus 5 is equal to 3 times the quantity x minus 8. To make this sign a little bit better. Okay, so this is just changing the sign of each term inside. So this would be negative x and then plus 5. This equals, this would be 3x minus 24. Let's go ahead and subtract 3x away from each side of the equation. And let's subtract 5 away from each side of the equation. So this is going to cancel, and this is going to cancel. Negative x minus 3x is going to be negative 4x. And this equals negative 24 minus 5 is going to be negative 29. Let's divide both sides by negative 4. And we really can't simplify that fraction that gets formed because 29 is a prime number. So we get x is equal to 29 fourths. So that's my solution. Okay, let's look at two word problems to wrap things up. So we have James purchases 6 gallons of premium gasoline for a total price of $19.56. A few moments later, Jennifer fills up her 15-gallon tank with the same premium gasoline. What was the price per gallon of gas? How much was Jennifer's bill? So we have two things to think about. First, what was the price per gallon of gas? Well, to get that, we're told here that James purchases 6 gallons of premium gasoline for a total price of $19.56. I would say, okay, well, if I spent $19.56 in total and I bought 6 gallons, well, I would just divide there. Okay, that's going to give me the price per gallon. So if I do that on my calculator, I get 3.26. So I'll put $3.26 per gallon. So that answers the first one. And then for the second one, it says, how much was Jennifer's bill? Well, we could take this $3.26 and multiply it by 15 to get her bill, but I think it's probably better to do it as a proportion. That's the idea behind this problem. So let's go ahead and set that up and say, okay, well, we have 19.56 in this one case over 6, and then I'm going to set this equal to, she has 15 gallons of gas. Let me put that down here. And then up here, it's X dollars. Okay. So I'm just going to solve this by cross multiplying. Again, you don't have to do this. You could just multiply 3.26 by 15 and you'd be done. But let's just do this for the sake of some practice. So we'll have 6 times X, which is 6X, which is equal to 15 times 19.56, which is going to be 293.4. And then we're going to divide both sides here by 6 and get X is equal to, this would give me 48.9. So that tells me she spent $48.90. So we'll just come back up here. And my second answer is going to be $48.90. So this first one is basically what is the price per gallon? It's $3.26 per gallon. And the second one, how much was Jennifer's bill? It's $48.90. Again, if you did this on your calculator, $3.26 or 3.26 times 15, you would also get this 48.90. Again, her total bill. Okay, let's look at problem number 12. So when using Maxine's super degreaser for pots and pans, 1/4 of a cup of the degreaser should be mixed with 1 gallon of hot water. How much of Maxine's super degreaser should be mixed with 10.5 gallons of hot water? Okay, so we're just going to solve this using a proportion. You could do it other ways, but I think this is probably the easiest way. So let's go through here. It says 1/4 of a cup of degreaser mixed with 1 gallon of hot water. So let's put 1/4, or you could do 0.25 if you want. That's probably better. So 0.25 over 1, and then we'll set this equal to, over here, it's going to be how much super degreaser, so let's put X for that, should be mixed with, this is going to be 10.5, so let's put 10.5 down here. And again, you could solve this in different ways, but we just want to cross multiply. So let me slide down here real quick. 0.25 times 10.5 is 2.625. And I'm going to set that equal to 1 times X is just X. So this is what you need in terms of gallons to be mixed with this 10.5 gallons of hot water. So let's go ahead and say that the answer there is 2.625 gallons. All right, let's take a look at our practice test. We're told to solve each equation for the given variable. And for the first problem, we're asked to solve for C. And what we have is F is equal to 9/5 times C, then plus 32. So let me write this again. This is F is equal to, we have 9/5, which is multiplied by C, and then plus 32. So you might notice that this is the temperature conversion formula for going from a temperature in Celsius to a temperature in Fahrenheit. Okay, so we're actually going to solve this for C, and we're now going to have a formula that allows us to plug in something for Fahrenheit and get a temperature out in Celsius. So if I want to isolate this C guy right here on one side of the equation, the very first thing I need to do is isolate the term that contains C in it. So I want to isolate this guy first. So how do I do that? Well, I have this plus 32 that's being added to it. So I would subtract that away from both sides of the equation. So let's go minus 32 over here on the right, and let's go minus 32 over here on the left. On the right, this is going to cancel and become 0. So on the left, let's write this as F, and then I'm going to go minus 32 is equal to, I have 9/5 multiplied by C. Now, because I like what I'm solving for to be on the left-hand side, I can legally just switch this around and write this as 9/5 times C like this is equal to F minus 32. You don't have to do that. It's just my personal preference. And what I'm going to do from here, if I want to isolate c, again, what's being done to c? It's being multiplied by 9/5. So I can divide both sides of the equation by 9/5 to get rid of that, or more quickly, I can just multiply by 5/9. So I'm going to multiply this side by 5/9 and make sure you use parentheses there because 5/9 is multiplied by the f and also the negative 32. And of course, this guy right here is going to cancel. This is just 1. So what we get is c is equal to this 5/9 times the quantity f minus 32. And you can leave it like this, or you could distribute the 5/9 into each term. It's really going to be up to you. I'll just leave my answer like this. All right, let's look at problem number 2. We're asked to solve for t. And that t there is actually standing for time. This is the formula you may know from solving motion word problems. We're going to get to this in the next section, where distance is equal to the rate of speed times the amount of time traveled. So t is for time traveled. So I'm just going to solve for t. And to do that, again, what's being done to t? It's being multiplied by r. So I can just divide both sides here by r, and it's going to cancel over here and be 1. And so essentially what I get is that t, or the time, is equal to, we're going to have the d, or the distance traveled, divided by the r, or the rate of speed. Okay, so this is solved for time. All right, let's take a look at problem number 3 now. So we're told to solve for f. And of course, this is us solving for Fahrenheit. We saw this formula earlier. Right now, we can plug something in for Fahrenheit and we'll get a temperature in Celsius, but we're going to reverse that. So let me just rewrite this. We have c is equal to 5/9, then times the quantity f minus 32. Okay, so to solve for f, what you could do first is use your distributive property. So you could distribute the 5/9 to the f, and then you could distribute the 5/9 to the negative 32. But I think it would be much quicker here to divide both sides of the equation by 5/9, or of course you could just multiply by the reciprocal, which is 9/5. So what that is going to do for us is clear this part right here. And so on the left-hand side, I have my 9/5 times c. On the right-hand side, I just have the f minus 32. If I want to solve this guy for f, what do I need to do? Well, right now I just have this 32 that's being subtracted away, or you can think about that as adding negative 32, whatever you want to do. So I'm just going to add 32 to both sides of the equation. And again, I like my variable that I'm solving for on the left. So I'm just going to rewrite this and say that I have f is equal to, we'll say on the right-hand side, we have this 9/5 c, and then plus 32. So in other words, now I could plug something in for Celsius, multiply by 9/5, and then add 32, and I'd have my temperature in Fahrenheit. Okay, let's look at problem number 4. We're asked to solve for h, and this h here is going to be height. So v for volume is equal to L, which is the length, times W, which is the width, times h, which is the height. So we're solving for h, or the height. And again, all you're doing here is you're trying to isolate h on one side. So what's being done to it? It's being multiplied by the L and the W. So let's divide both sides of the equation by L times W. Let's go ahead and do that. And I'm going to cancel this L with this L and this W with this W. And you'll have height isolated on the right. And of course, you could switch that around. I'm going to put h on the left, and I'll set this equal to, I'll put the V, which is the volume, over the L, which is the length, times the W, which is the width. Okay, let's look at problem number 5. We're asked to solve for h, which is height again. This is for the area of a triangle. That's where this formula comes from. So the area is equal to 1/2 times the base times the height. So if I want to solve for height, again, I've got to undo what's being done to it. It's being multiplied by 1/2 b. Okay, so I'm going to multiply here by the reciprocal of that, which is basically going to be 2 over b. Okay, you can think about this. Let me erase this and put this as b over 2 so this is more clear. And then I'll multiply this side by 2 over b, like this. And then again, we can show this as canceling. So this 2 with this 2, and this b with this b. And on the right-hand side, I just have h by itself. So it's solved for the height like I wanted. And I'll say h, the height of this given triangle, is equal to, we're going to have 2 times a, which is your area, over your b, which is going to be your base. Okay, let's look at problem number 6. We're asked to solve for x. So here we have this a is equal to 2xy squared plus 2xyz. So if I want to solve for x, you would notice that you have it here and you have it here. So normally the first step is to move all the variable terms with that variable in it to one side, but we actually already have that. So now what I'm going to do is actually factor things and say that I have a is equal to, I'm going to pull the x out in front of a set of parentheses because it's here and here. So again, I'm just pulling that out right there. Inside the parentheses, I'm going to have 2y squared, and then plus, I'm going to have 2yz. Okay, now I didn't pull out everything that was common because I'm trying to solve for x. So I'm getting that out here so I can isolate it. Now I have it as x being multiplied by some quantity. Okay, so if I want x by itself, I just need to undo this multiplication. And of course, I can do that with division. I can divide both sides here by the quantity 2y squared plus 2yz like this. And I don't think I gave myself enough room. Let me do this on this side. So this is the quantity 2y squared plus 2yz like this. And of course, this is going to cancel. And we'll have, I'm just going to write this in a different order. I'm going to put x on the left. This will be equal to, you have your a over this 2y squared plus 2yz. And then, of course, you might want to report an answer with a factored denominator. This is completely optional. It's really up to your teacher. I'm going to put a over from the denominator here. I'm going to factor out a 2y. And I'm just going to have a y plus z inside. So again, either of these answers would be acceptable if you're doing self-study. If you're in a course, then just ask your teacher what they prefer. All right, let's take a look at problem number 7. We're asked to solve for x. Let's slide down here for a moment. We have y minus y sub 1 is equal to m times the quantity x minus x sub 1. So many of you remember this formula from basic algebra. This is the point slope form of a line, and we'll get to this later on in the course. For right now, we want to solve for x. Let me rewrite this. I'm actually going to switch the sides. So I'm going to put m times the quantity x minus x sub 1 is equal to y minus y sub 1. And the first thing I'm going to do, since I'm trying to solve for x there, you could use your distributive property and multiply m by x and then m by this negative x sub 1. But I think it's a lot quicker to just divide both sides of the equation by m so that we can just clear that and not have to worry about it. So that's going to cancel. And then it becomes pretty simple what I need to do. I have x minus x sub 1 is equal to y minus y sub 1 over m. Let's slide down here a little bit. Well, what's being done to this x is I'm subtracting away this x sub 1. So I need to undo that. So I'm just going to add x sub 1 to both sides of the equation. And so I'm going to say that this cancels. And we have x is equal to y minus y sub 1 over m, and then plus this x sub 1. Now, you can leave your answer like this, or if you wanted to have a common denominator, which many teachers would want that, it's really up to them, what you could do is you could multiply this x sub 1 by m over m. So you could say you have x is equal to y minus y sub 1. Again, if I multiply this by m over m, this would be plus m times x sub 1 over the common denominator of m. So however you want to report your answer, it's really up to your teacher. If you're doing self-study, then just pick one. Okay, let's look at problem number 8. So we're asked here to solve for z. So what we have is y is equal to negative az minus b over xz. So I've got to get everything with z, all those terms, to one side of the equation. And right now you have this guy and you have this guy. So what can I do? Well, the first thing is I can multiply both sides by xz. So I would have xzy is equal to, if I multiply this side by xz, it's going to cancel. So negative az minus b. So I've got to move this term over here, or you could move this term over here. It's really up to you. But I've got to get all the terms with z in it to one side. So let's slide down here and let's add az to both sides of the equation. And we'll say that we have az plus, and I'm just going to write this as xyz. And then we'll say this is equal to negative b. Okay, let's slide down here. So we saw this earlier. How can I get z by itself? Well, I have it here and I have it here. And so I can factor it out, right? Because this is addition here. So what I'm going to do is pull this out in front of a set of parentheses. So I'll have z times the quantity a plus xy, like this. And this equals the negative of b. This quantity here is multiplying z. I can divide both sides by this a plus xy. So divide by a plus xy. You could use the parentheses or not. It really doesn't matter. It only matters here. So let's just go ahead and cancel this with this. And we'll say z is equal to negative b over this a plus xy, Or of course, you could write xy plus a. Really, again, it's up to you how you want to write it. All right, let's look at problem number 9. We're asked to solve for z. Let's slide down here. We have yz plus m is equal to z plus 4 over x minus 1. So if I'm solving for z, again, I've got to get all the terms with z in it to one side of the equation, everything else to the other. So what I'm going to do is multiply both sides by the quantity x minus 1 so I can clear this denominator. So let's go yz plus m times the quantity x minus 1. This will be equal to z plus 4. So let's start with that. So here I'm going to use FOIL. We have yzx. Let me change colors here. So we'll have yzx. So let me write xyz. And then we'll have minus this yz. And then plus mx and minus m. So that's what this side is going to simplify to. And you have equals z plus 4. Okay, so I want to solve this for z. So again, you have a z here, you have a z here, and you have a z here. So I want to take all the terms with z and move them over to one side. Move everything else to the other. So I'm going to subtract z away from here and here. And I'm going to subtract mx away from here and here. And add m to here and add m to here. Let me slide down. What does that give us? We're going to have x, y, z minus yz minus z. This is going to cancel. This is going to cancel. This equals. This is going to cancel. So you have 4 minus mx and then plus m. If I look at this guy again, you have your z, your z, your z. You could factor that out. And so let's pull that out in front of a set of parentheses and put z here. And you'll have xy minus y and then minus 1. This equals 4 minus mx and then plus m. And if we want to solve for z, we can simply divide both sides of the equation by this xy minus y minus 1. I'm going to divide over here. Again, you don't need parentheses. So I'm going to do xy minus y minus 1. And let's go ahead and cancel this with this. We'll say that z is equal to this 4 minus mx and then plus m over xy and then minus y and then minus 1. All right, let's look at problem number 10. We're asked to solve for x. I'm just going to tell you in advance, this one's pretty tedious. So we have on the left this m squared x minus a squared x. So let me actually wrap this in parentheses. And what we're going to do, to clear this denominator, I'm going to multiply both sides by this quantity y plus 1. And this will be equal to, you'll have your z plus b minus x. Now what I'm going to do actually is add x to each side of the equation now, just to get rid of it. So I'm going to put plus x here and plus x here, and I'll cancel it from over here. So what's going to happen is I'm going to do FOIL over here and then just add x to that. So let's just say m squared x times y. That's going to be m squared xy. And then this is going to be times 1. So plus m squared x. And then we're going to go minus this guy times this guy. So a squared xy. And then lastly, it's going to be this guy times this guy. So it's minus, and we're multiplying by 1. So a squared x. Okay, no like terms to combine. So I'm just going to add. Remember, I have this plus x here. So I'm going to put plus x there. And this equals z plus b. So basically, on the left-hand side, everything has an x. You have an x there, and there, and there, and there, and there. On the right-hand side, you don't have an x. So basically, the first part where you get all the variable terms to one side and everything else to the other, that's done. So what I would do here is actually factor the x out. So pull it out from there, and there, and there, and there, and there. And if you pull that out, you have an x out in front, and then you have the m squared y plus the m squared, and then minus the a squared y, and then minus the a squared, and then basically plus 1. Okay, so this equals your z plus b. And of course, to get x by itself, I'm just going to divide both sides by this. So I'm going to divide both sides by this m squared y plus m squared minus a squared y minus a squared plus 1. Let me do this over here. Who knows if I can fit this? So I'm going to try. So m squared y plus m squared minus a squared y minus a squared plus 1. Okay, so it looks like it does fit. So this is going to cancel, right? So same thing over itself. As long as it's not 0, it's always going to be 1. So this is going to be x is equal to, you have your z plus b, and this is over. Let's go ahead and say m squared y, and then plus m squared, and then minus a squared y, and then minus a squared, and then plus 1. So that would be your solution. Again, how you want to arrange things is really up to you, but this is what you can put for your answer. All right, let's take a look at the practice test. We're told here to solve each inequality, write in interval notation, and then also we will graph. All right, let's start off with this first problem here. We're given 315 is greater than or equal to -5 times the quantity 1 minus 8x. Now, when you're solving an inequality, you use pretty much the same steps that you would when you're solving an equation. There's only one main difference, and that is if you're multiplying or dividing both sides of the inequality by a negative value, you need to make sure you flip the direction of the inequality symbol. So that's something you need to keep in mind. So for this guy, I'm just going to start by writing my 315 on the left-hand side. Nothing I can do with that. This is greater than or equal to. I'll just use my distributive property here to clean up. I'm going to have -5 times 1, which is -5. And then we'll have -5 times -8x, which will be plus 40x, like this. And then from here, when I look at my guy, basically I would just want to move this guy over to the other side. So what I'm going to say is plus 5 over here, and then plus 5 over here. So that's gone. And basically you have 320 is greater than or equal to 40x. Now, if you watch my videos, then you know I like my variable to be on the left. This, again, is just personal preference. So what I'm going to do is just rewrite this. And if you're going to do this, just pay close attention to which direction the symbol points. So I'm going to rewrite this as 40x is less than or equal to 320. So it's the same as saying 320 is greater than or equal to 40x. I'm saying 40x is less than or equal to 320. So just make sure if you do this that the symbol is pointing in the right direction. Here it's pointing towards 40x. Here it's pointing towards 40x. So that's what you want to check. All right, as a final step here to isolate x, you'll notice that you have this 40 that is multiplying it. So I'm just going to divide both sides of the inequality by 40. And I'm going to find that x is less than or equal to 320 divided by 40 is going to be 8. So this is my solution, and let me come down here to the number line, and I'm just going to write this in interval notation. Basically, you're going to have these two positions here. You have a smallest and a largest. In this case, the largest that x can be is 8, right? Because it's less than or equal to 8. So let me put an 8 here. And because it's included, I'm going to put a bracket there, okay? Now, for the smallest possible value for x, there isn't one, because it could be anything that's less than or equal to 8. So I'm going to put -infinity here. And then if I'm using infinity or negative infinity, I'm always going to put a parenthesis next to that, okay? Now, graphically, I'm just going to kind of match up what I see here. I'm going to go to +8 on the number line. And basically, I'm going to put a bracket that faces to the left, and I'm going to shade everything to the left like this, including that arrow, just to say that all numbers from 8 and going down to -infinity would satisfy my inequality. Now, just a point here, some textbooks, instead of using a bracket, will use a filled-in circle. If your textbook does that, then you can do that. But in most cases, it's just a matter of personal preference. Okay, let's look at the second problem. And we're going to have -133 is greater than 7 times the quantity 2x minus 3. So what I'm going to do is actually just flip this now. So I'll say 7 times the quantity 2x minus 3. Again, the symbol is pointing to this, so I want it pointing to this again. And then, so this is less than now. I'll say -133. So let's clean up the left side. I'm just going to distribute the 7 to each term. 7 times 2x is 14x. And then minus, we know that 7 times 3 is 21. This is less than -133. So again, I've got to isolate this 14x. So I'm just going to add this 21 to both sides of the inequality. And let's cancel this out from over here. So what I'm going to have is 14x is less than, if you do -133 plus 21 in your calculator, you're going to get -112. And of course, if we want to isolate x, you've got this 14 that's multiplying x. So let's divide both sides of the inequality by 14 to finish up this process. And so what I'll say here is x is less than, we know this is negative. Let's punch up 112 divided by 14 into our calculator, and that's going to give me 8. So here x would be less than -8. Okay, so again, with the interval notation, you want to think about the smallest value and the largest value. So in this particular case, the largest value, let's just put -8, although -8 is not included. And to identify that -8 is not included, here we're going to use a parenthesis. If -8 was included, so if I had this guy, then I'd be using a bracket, right? But that's not what we have. -8 is not included, so we show this with a parenthesis. Now again, for the smallest possible value, we don't have one, so we're going to put -infinity, and we'll use a parenthesis with that. So this would be your interval notation. Of course, you don't need these underlines here. That's just for me to show things. And graphically, I'm just going to put a parenthesis here at -8. Let me change my color up, actually. So I'm going to put a parenthesis at -8 to show that it's not included. And I'm going to shade everything going to the left like this. In your textbook, it might show an open circle, again, just to show that it's not included. So just go with whatever you want to do or whatever they're doing in your class. Okay, let's look at problem 3. So we have -106 is less than -2 times the quantity 7x minus 3. Let me flip this around and put -2 times the quantity 7x minus 3. And again, the symbol is pointing to the -106, so I'm going to keep it that way. So I'll say it's greater than the -106. So just pay attention to where it's pointing if you want to rewrite it. So what I'm going to do here is, again, just distribute to clean up. -2 times 7x is -14x. The -2 times -3 is +6. This is greater than -106. What I'll do from here is just subtract 6 away from each side of the inequality. So that's going to cancel. So now I have the -14x on the left by itself. And this is greater than, if you do -106 minus 6, that's -112. So we want to isolate x, and you'll notice that you have a -14 that's multiplying x. And here's where you got to think about your rule. If I divide both sides of an inequality by -14, well, because it's negative, what's going to happen is we have to flip the direction of the inequality symbol. Right now it's a greater than, it's going to have to turn into a less than. Okay, if you don't do that step, you're going to get the wrong answer. So it's really important to remember that. So this would cancel as it always does. And this would be x is now less than. Now we did something similar in the last example, so hopefully you remember the answer. If you don't, just punch it into your calculator. -112 divided by -14 would be +8. Okay, so writing my solution in interval notation, again, we'll just set this up this way. What's the largest possible value? Well, I can't actually have 8, but I'm going to list that there. And I'm going to put that parenthesis there to show that it's not included. And for the smallest possible value, I'm going to put -infinity. Again, graphically, I'm going to find 8 on the number line. I'm going to put a parenthesis there, or again, if you want to use an open circle, that's up to you. And then I'm going to shade everything going to the left, including that arrow, to show that all those values are included. Let's look at a fraction example. For problem number 4, we have 309/56 plus 6x is greater than or equal to -6/7x minus 1/2x. Now, we can have fractions or decimals in these types of problems. You would clear them in the exact same manner that you would if you had an equation. So, for example, I could figure out what is the least common denominator with 56, 7, and 2. Well, it turns out that 56 is what? 56 is going to be 8 times 7, and 8 is 2 cubed. So 2 cubed times 7, and you have 7 and 2 here, so the LCD is just going to be 56. So if we multiply everything by 56, again, if you need to, you can pause the video and just do it to each one and show yourself what's going on. I'm just going to do this more quickly. So 309/56 times 56, obviously the denominator would cancel, and you would just have 309. Then plus 6x times 56 would be 336x. This is greater than or equal to. I know this will be negative, so let me just write that in advance. If I do 56 divided by 7, that's 8, and 8 times 6 is 48. So this will be minus 48x. And then I'm just going to put the minus again. If I do 56 divided by 2, that's 28. So this would be minus 28x here. On the right-hand side, I can combine like terms. So negative 48x minus 28x is going to give me negative 76x. And over here, I just have I'm going to write 336x plus 309. So just like if we were working with an equation, we want to move all the variable terms to one side and all the numbers to the other. So what I would do is I would add this 76x to both sides of the inequality, like this. Let's subtract 309 away from each side of the inequality, like this. And let me show this is canceling and this is canceling. And what we'll have here is 336x plus 76x. That's going to be my left-hand side. That would be 412x. This will be greater than or equal to. Over here, I'll just have the negative 309. What I'll do to finish this up, since you have 412 that's multiplying x, I'll divide both sides of the inequality by 412, and I'll have x is greater than or equal to. I know this is negative. If you punch this into your calculator, if you do the division, you get 0.75. Now, you might want to answer negative 0.75 like this, or you may want to give your answer as a fraction. We know this would be negative 3/4. But again, if you wanted to go through and factor it, 309 would factor into 103 times 3, and 412 would factor into 103 times 2 times 2. So you can see that you can cancel a factor of 103 between the numerator and denominator. And again, you end up with negative 3/4. So however you want to write this, again, your teacher may give you a certain preference, but I'm going to say x is greater than or equal to negative 3/4. So x is greater than or equal to negative 3/4. In interval notation, I would put a bracket right here next to negative 3/4. That is the smallest that x can be. And then going out to positive infinity, right? There is no largest value. So let's go ahead and put a parenthesis next to infinity. And then graphically, we don't have a notch for negative 3/4, but we can make one. We know that this is 0. We could say this is negative 0.5 or negative 1/2. And then go a little bit closer to negative 1. Let's say it's about right here. I'll go ahead and say that's negative 3/4, like this, or negative 0.75, however you want to say that. And basically, I would want to, let me use an orange here, I would want to put a bracket at this value here, this negative 3/4, to show it's included. Or again, you can put a filled in circle. And then I would shade everything to the right to show that all values going to the right out to positive infinity would satisfy my inequality. Okay, let's look at problem number 5. I'll tell you in advance, this one's pretty tedious. So you have 367 over 168 plus x plus 1/3 plus 7/8 x is greater than or equal to 1/3 x plus 13/7. Now again, you can clear the fractions by finding the LCD. So you know that 8 is 2 cubed. Now what is 168? Well, it turns out that it's 7. Let me write this out. This is 7 times 8, or 2 cubed, and then times 3. So basically your LCD would be that 168. So let's multiply both sides of the inequality by 168. Obviously, this would be 367 there because the 168 would cancel. Then plus, you'd have 168x. Then plus, if I divide 168 by 3, I would get 56. So let's put that there. And for the sake of room, you could add this right now. So 367 plus 56 would be 423. Let's just do this so we don't have to run out of room. So 423. Over there, and then now moving on to this one. So 7/8 x times 168. So 168 divided by 8 is 21. And then if I do 21 times 7 in my calculator, I would get 147. So let's go 147x like this. This is greater than or equal to. We already know that for 1/3 multiplied by 168, we get 56. So let's put 56x here, then plus 168 divided by 7 is 24. And then if I multiply that by 13 in my calculator, I'm going to get 312. All right, so from here, it's just a lot of simplifying. So on the left-hand side, it looks like I can do 168x plus 147x. That would give me 315x. So let's say we have 315x plus 423. This will be greater than or equal to, you have 56x plus 312. All right, so I want all the variable terms on one side of the inequality and then all the constants on the other. So let's subtract 423 away from each side of the inequality. And let's also subtract 56x away from each side of the inequality. And let me show that this is going to cancel here, and this will cancel here. So 315x minus 56x would be 259x. Then this is greater than or equal to. If I do 312 minus 423, that's negative 111. And let's divide both sides of the inequality by 259. And what is this going to give me? So x is greater than or equal to, we know it's negative. Let's see, this is divisible by 3. Let me write this as 3 times 37. This is also going to be divisible by 37. It's going to end up being 7 times 37. So let's cancel this common factor of 37 here. We'll say x is greater than or equal to negative 3/7. So this negative 3/7 here. So for my interval notation, again, I'm going to put a bracket here, and then I'll list negative 3/7 as the smallest value. Again, it's included because we have the or equal to part there. So that's why I have the bracket. I'll put a comma, and this is going to, in terms of the solution, go out to positive infinity. We'll put a parenthesis there. And then graphically, again, our notches are in terms of integers. But if you punch negative 3 divided by 7 into your calculator, you get about negative 0.4, let's say 3. Okay, if you were to round. So if I go on the number line, I know that about right here would be negative 0.5 or negative 0.5. It would need to be a little bit closer to 0 than that. So let's just put it about right there and say, again, this doesn't have to be perfect. You would just notate this for your teacher and say this is -3/7. And as long as it's close enough, they'll give you the credit. So what I want to do here is put a bracket there. Again, if you want to use a filled in circle, that's fine. And then I'm just going to shade everything to the right to just show that all those values are included in my solution set. All right, let's look at problem number 6 now. So we have 4 times the quantity x plus 5 minus 5 is greater than or equal to the negative of the quantity 3x minus 3 and then plus 5. On the left-hand side, we'll have 4x and then plus 20. Then minus 5 is greater than or equal to. On the right-hand side, you're going to change the sign of each term inside the parentheses. So negative 3x and then plus 3 and then plus 5. Okay, so on the left-hand side, 20 minus 5 is 15. So let's go 4x plus 15 like this is greater than or equal to. On the right-hand side, 3 plus 5 is 8. So negative 3x plus 8 like this. Again, all the variable terms need to go to one side. All the numbers or constants need to go to the other. So let's subtract 15 away from each side of the inequality. And then also what I'm going to do is add 3x to both sides of the inequality. Let's show this as canceling here and then also here. And then 4x plus 3x would give me 7x. This is greater than or equal to. 8 minus 15 would be -7. All right, so one more step here. I'm just going to divide both sides of the inequality by 7, and we get x is greater than or equal to -7/7 is -1. So for interval notation, again, the smallest possible value, I'm going to put a -1 there, and then I use my bracket because it's included. I'll put comma. This is going to go out to positive infinity, and then I'll put a parenthesis there. I'm going to find -1 on my number line. So let's go ahead and put a bracket there, or again, a filled in circle if that's what you want. And I'm just going to shade everything to the right. Again, all these values going out to positive infinity. Okay, let's look at problem number 7. So we have 4 times the quantity x minus 1 is less than or equal to -2 times the quantity x plus 5. So let's just use the distributive property to clean up. I'll have 4x minus 4 is less than or equal to, this would be -2x, and then -2 times 5 would be -10, so let's put -10 there. And again, all the variable terms go to one side, all the numbers to the other. So let's add 4 to both sides of the inequality. And then let's also add 2x to both sides of the inequality. And what is this going to give me? This would cancel, and this would cancel. 4x plus 2x is 6x. This would be less than or equal to -10 plus 4 is going to be -6. And let's divide both sides of the inequality by 6. This would cancel. You'll have x is less than or equal to. -6 divided by 6 would be -1. Okay, so x is less than or equal to -1. In interval notation, for the smallest value, we're going to put -infinity because it's going to go to the left forever. So from -1 out to -infinity. So for the largest possible value, let's put -1. It's included, so let's put a bracket there to show that. So let's go to -1. I'm going to put my bracket there, or again, you can use the filled in circle. And I'm going to shade all these values here going to the left. Let's take a look at problem number 8 now. So we're going to have 5 times the quantity x minus 1. This is less than 4 times the quantity x minus 4, then plus 2. So let's use our distributive property to clean this up. We'll have 5x, and then -5 is less than. We'll have 4x, and then -16, and then plus 2. On the right-hand side, -16 plus 2, let's just write that as -14. Just clean that up right there. And then what I want to do from here is just add 5 to both sides of the inequality and cancel this. I'm going to subtract 4x away from each side of the inequality. And let's cancel this. So 5x minus 4x is going to give me x. This will be less than -14 plus 5 would be -9. So x is less than -9. So in interval notation, again, for the smallest possible value, let's put -infinity there. Let's put a comma. In the largest possible value position, we'll put a -9. It's not included because this is strictly less than. So I'm going to put a parenthesis next to that to show that. And again, if you're graphing this, go to -9 on the number line. We can put an open circle to show that -9 is not included. Or again, I'm going to use a parenthesis for that. And then I'm just going to shade everything to the left. Okay, let's look at problem number 9. So here we're going to have 4 times the quantity x plus 1. Then -2 times the quantity x plus 2. This is greater than -5x minus 3x. Okay, so on the left-hand side, let's clean up. We'll have 4x plus 4. Then I'm going to treat this as -2 when I'm multiplying, so -2x or -2x. And then I'll have basically -4. and this is greater than, let's go ahead and combine like terms here. Negative 5x minus 3x would be negative 8x. And then on the left-hand side, you could do 4x minus 2x, that's 2x. And then 4 minus 4 is 0. So you could just put 2x is greater than negative 8x. So when you see something like this, remember, you still want all your variable terms on one side. So what I'm going to do is I'm going to add 8x to both sides of the inequality. And remember, when this cancels, it's actually 0, right? Negative 8x plus 8x is 0. So you need to make sure you write that. A lot of people get lost on that step. So 2x plus 8x would be 10x. This is greater than 0. Of course, if I divide both sides of the inequality by 10, I'll cancel this and I'll say x is greater than 0. Okay, so in interval notation, let's put a 0 here for the smallest value. Again, it's not included, so it's not the actual smallest value, but we'll put a parenthesis next to it to show that. And then it goes out to positive infinity, and we'll put a parenthesis next to that. So I'm going to find 0 on my number line. And what I want to do is use an open circle, or again, I'm just going to use a parenthesis, and then I'm going to shade everything to the right, including the arrow. Okay, let's look at 10. This will be the final problem. We have x minus 4 times the quantity 3x plus 3. This is less than or equal to 4 times the quantity negative 3x minus 3, and then plus 4x. Okay, let's start by cleaning up. We have x. I'm going to treat this as negative 4. So negative 4 times 3x, that would be minus 12x. Then negative 4 times 3, let's go minus 12. This is less than or equal to. Over here, 4 times negative 3x is negative 12x. And then 4 times negative 3 is minus 12. And then plus 4x. Now, what you'll see is that you have a negative 12x here and a negative 12x here. Again, we know at this point we could cancel it because we could add 12x to both sides of the inequality. And this would go away and this would go away. You also have negative 12 and negative 12. Again, you could just add 12 to both sides of the inequality. And this is going to cancel in each case, so that's gone. So what am I left with? I have x is less than or equal to 4x. Again, just like in the last problem, what you'd want to do is subtract 4x away from each side of the inequality. Let's cancel it over here and put a 0. Don't forget that. So x minus 4x would be negative 3x. This is less than or equal to 0. And of course, to finish this up, I'm going to divide both sides by negative 3. Now, this is something, again, you need to remember. Because I multiply or divide by a negative number, I must flip the direction of the inequality symbol. If I don't remember to do this, I'm going to get the wrong answer, okay? The number on the right-hand side will still be correct, but the symbol that you're using will be wrong. So this is going to cancel, and I'll have x, instead of a less than or equal to, I want a greater than or equal to. 0 divided by negative 3 would be 0. So what I want here, for x is greater than or equal to 0, let's put a bracket here next to 0, because 0 is included. And this will go out to positive infinity. Let's put a parenthesis there like that. So I'm going to find 0 on my number line. Let's put a bracket there to show it's included. Or again, if you want to use a filled-in circle, that's up to you. And we'll shade all these values going out to the right to positive infinity. Again, all of those would satisfy the inequality. Let's take a look at the practice test. We're told to solve each, write in interval notation, and then graph. All right, for the first problem, we're going to have that 7x is greater than or equal to negative 28, and it's less than or equal to 63. So this type of inequality is known as a three-part inequality, and you solve it in a similar way. What you're going to try to do here is isolate x in the middle, and so you're going to do the same thing to each part. So for example here, if I think about what's being done to x, it's being multiplied by 7. So to undo that, I'm just going to divide by 7, but I need to do that to each part here. So in other words, I'm going to divide this by 7, this by 7, and this by 7. On the very left, negative 28 divided by 7 is going to be negative 4. Then I'm going to put my less than or equal to symbol. Then 7 divided by 7 is 1, so I just have x. Then I'll put another less than or equal to symbol. And 63 divided by 7, all the way here on the right, is going to be positive 9. So this gives me a solution where I say x is greater than or equal to negative 4, and it's less than or equal to 9. And let's think about this in interval notation, and also let's graph this on the number line. So I know for the smallest possible value, it says that x needs to be greater than or equal to negative 4. So let's put a bracket, and let's put negative 4. So that's the smallest x can be. Then the largest x can be, again, it's got to be less than or equal to positive 9. So let's put a 9, and then let's put a bracket there. So that would be my interval notation. And pretty much when you graph this guy, you're going to match this interval notation. You're going to find negative 4 on the number line. And I'm going to put a bracket there, or again, some books will put a filled-in circle. Then I'm going to go to positive 9. I'm going to put a bracket there. Again, some books will put a filled-in circle. And then I'm just going to shade everything in between. So to satisfy this inequality, x can be anything starting from -4 and going up to and including this positive 9. Okay, let's look at problem number 2. So here we have x over 3 is greater than or equal to 0 and less than 2. So what I need to do here is think about how to undo what's being done to x in the middle. So right now x is being divided by 3. So what I can do is I can multiply each part here by 3. So in other words, I can say that I have 0 times 3 is less than or equal to, I'll say x over 3 times 3, and I'll put the less than here, and then I have 2 times 3. Okay, so let's go through here. 0 times 3 we know is 0, and then I can cancel these 3's here. So let me put is less than or equal to x, which is less than 2 times 3 would be 6. So my answer becomes that x is greater than or equal to 0 and less than 6. Okay, so interval notation here is a bit tricky because we have mixed inequalities, right? So we have one that's a non-strict inequality and one that's a strict inequality. So what I'll do is for the smallest possible value, I'm going to list 0, and it's going to be included. So I'm going to have a bracket there because we have a non-strict inequality. We have x is greater than or equal to 0. So it can be 0. Then I'm going to put a comma. And then for the largest value, I'm going to put 6, even though it's not actually included, right? The 6 is not the actual largest value, but we're going to list it there. X is strictly less than 6. So to show that it's not included, I'm going to put a parenthesis there. And then basically, I'm just going to match this format up when I look at my number line. So I'm going to find 0. I'm going to put a bracket there. And then basically, I'm going to find 6. And I'm going to put a parenthesis there. And I would note here that some textbooks, instead of the parenthesis, they'll use an open circle, right? And you already know that some books, instead of using a bracket, will use a filled-in circle. So use your personal preference or whatever your teacher says. But we just want to fill all this in right here. So basically, x can be 0, and then anything up to, but not including, positive 6. All right, let's take a look at problem number 3. We're going to have 3 plus x is greater than or equal to 3 and less than or equal to 1. Okay, what I'm going to do to start things off, since 3 is being added to x, I'm just going to subtract 3 away from each part here. And let's cancel this in the middle. And what I'll have is x is greater than or equal to, 3 minus 3 is 0, and less than or equal to 1 minus 3 is going to be -2. Now you can stop for a minute and see that this does not make sense. If I gave you the inequality 0 is less than or equal to -2, that is a false statement. 0 is to the right of -2 on the number line. So 0 is a larger value, right? 0 or some positive value is always larger than any negative value. So 0 is not less than -2, and it's certainly not equal to it. So this statement right here is false. So we know if we have something like this that we're not going to have a solution. So we can just stop and write no solution here, because essentially what I'm asking for is for a value to be plugged in for x that's going to be both greater than or equal to 0 and less than or equal to -2. If you wanted to look at this on the number line so that it's crystal clear, think about the first part of this. X needs to be greater than or equal to 0. So let's come to 0. Let's put a bracket there and let's shade everything to the right. So numbers from 0 and including 0 out to positive infinity would satisfy the first part. The second part, let's say x is less than or equal to -2. Well, that would be a bracket at -2 and shade everything to the left. So starting at -2 and going down to negative infinity. And so you see there's no overlap here. There is no number that I can find such that it's going to be greater than or equal to 0 and less than or equal to -2. So again, that's why we say there's no solution for that problem. Okay, so for problem number 4, looks like we have that 3 minus 3x is greater than -15 and less than or equal to 0. So what I'll do here is I'll subtract 3 away from each part to get things started. So all the way on the left, -15 minus 3 would be -18. Then we'll have is less than. This would cancel. You'd have this -3x here. And then we have the less than or equal to. 0 minus 3 would be -3. Let me make this 3 a little bit better. Don't think that's very legible. All right, so x is not isolated in the middle, so we have another step here. We have -3 that is multiplying x. So I'm going to divide each part here by -3. And remember, if you multiply or divide an inequality by a negative, you need to flip the direction of the inequality symbol. So here you have 2 inequality symbols, so we need to flip both of those. That's very important here. So let's come down. Let's do our division. -18 divided by -3 would be +6. I'm going to flip this to a greater than. This cancels, and you have x. I'm going to flip this to a greater than or equal to, and then -3 over -3 is 1. So here we're saying x is greater than or equal to 1 and less than 6. Now, I would not leave it in this format. typically you want to write this to where the numbers that are involved in your problem match the way they look on the number line. So in other words, I would want to put a 1 here and a 6 here, an x in the middle, and then just match what you have. So we know that x is going to be greater than or equal to this positive 1, and it's going to be less than 6. So this is the format that I would write my answer. And then for my interval notation, it's pretty simple here. We would say, again, for the smallest possible value, I'm going to put a 1. And I'm going to have a bracket there because this is a non-strict inequality. So x is greater than or equal to 1. And then for the largest possible value, let's list 6, although it's not the actual largest value. And then because this is not included, because this is a strict inequality, let's put a parenthesis there. So let's find 1 on the number line. That's right here. Let's go ahead and put a bracket there. Let's find 6 on the number line. That's right here. Let's put a parenthesis there. And then let's shade everything in between there just to show that x can be positive 1 and then going up to but not including positive 6. Okay, let's look at problem number 5. So we have 2x minus 10 is greater than or equal to negative 14 and is less than or equal to positive 10. So let's add 10 to each part here. So add 10 to everything. So negative 14 plus 10 would be negative 4. We'll put the less than or equal to here. This would cancel. You'll have 2x. We'll have less than or equal to here. 10 plus 10 is 20. All right, so I have not isolated x yet. To do that, I'm going to divide each part here by 2. Again, the coefficient of x, so that that guy can be isolated. Let me slide down here a little bit. So let's say that this is going to cancel, and we'll have that x is greater than or equal to negative 4 divided by 2 is going to be negative 2. And then we'll say and it's less than or equal to 20 divided by 2 is 10. All right, so we have x is greater than or equal to negative 2 and less than or equal to 10. So in interval notation, let's put a negative 2 for the smallest value. Then let's put a positive 10 for the largest value. And those are both going to be included because we have these non-strict inequalities. So graphically, let me find negative 2. Let me put a bracket there. And let me find 10. Doesn't look like we have a notch for that, so let's put one in right there. Say that's good enough. Let me change the color up a little bit. And we'll say that that's my bracket there. And then we'll just shade everything in between. Let's maybe use orange here so it shows up real good. So that would be my solution graphically. All right, let's look at problem number 6. So here we're going to have that 4x minus 10 is greater than negative 46 and it's less than negative 6. So to start things off, I would try to isolate the 4x first. So I can do that by adding 10 to each part here. And what is that going to give me? Well, in the middle, this is going to cancel. All the way to the left, negative 46 plus 10 is going to be negative 36. So this will be less than my 4x, which is less than negative 6 plus 10 is going to give me positive 4. So then what we can do from here is divide everything by positive 4. This would cancel. So I would have x is greater than negative 36 divided by 4 is negative 9. We'll say and it's less than 4 divided by 4 is 1. So x is greater than negative 9 and less than positive 1. Now for the interval notation, you have strict inequalities in each case. So I'm just going to put a parenthesis, a negative 9, comma, a 1, and a parenthesis. So from negative 9 to positive 1, neither are included. That's why you have the parenthesis next to each. So let's find negative 9. Let's put a parenthesis there. Let's find positive 1. Put a parenthesis there. And then again, I'm just going to shade everything in between. So anything between negative 9 and positive 1 works as a solution. Again, where negative 9 and positive 1 are excluded. Okay, let's look at problem number 7. So we have negative 2 minus 4x is greater than negative 22 and less than positive 18. So let's add 2 to each part here. And what that's going to do is give me this negative 4x isolated in the middle. So I'll say this is greater than my negative 22 plus 2 would be negative 20. And then let me fix that. I'll put and it's going to be less than 18 plus 2 is going to be 20. All right, let me divide each part here by negative 4. Again, that's the coefficient of x. This is going to isolate x in the middle. So this is going to cancel away. Now, because I divided by a negative, remember you have to flip the direction of these inequality symbols. I'm going to divide this by negative 4 and this by negative 4. And what I'll say here is that I have x, and I'm going to flip each of these to greater than symbols like this. So negative 20 divided by negative 4 is going to be positive 5. And 20 divided by negative 4 is going to be negative 5. So I'm going to rewrite this in the order of the number line. So I'm going to put the negative 5 all the way over here on the left. I'll put the positive 5 all the way over here on the right. and I'll say that x is going to be greater than -5 and less than +5. Okay, so my interval notation here, let me put a -5 here and then a 5 here. And these two values are not included. We have a strict inequality in each case. So let me put a parenthesis here and a parenthesis here to show that. And then on the number line, let me use the orange. It seems to show up pretty nicely. Let's go to -5 and let's go to +5. Again, I'm using a parenthesis there to show that those are not included. And I'm just going to shade all the values between there. So x can be any number between -5 and +5. And again, those two values, -5 and +5, those are not included. All right, let's look at problem number 8. So we have here that 6x plus 5 is greater than or equal to 23 and less than or equal to 53. All right, so what I want to do again is isolate x in the middle. So first, let's subtract 5 away from each part so that I can isolate the 6x part. Let's get rid of this. So we'll have 6x in the middle. This will be greater than or equal to 23 minus 5 is going to give me 18. And this will be less than or equal to 53 minus 5 is going to be 48. All right, so I want to isolate x, and we have 6 that's multiplying x. So let's divide each part here by 6. And so all the way on the left, 18 divided by 6 is 3. This would be less than or equal to, this is going to cancel and give me x. We'll say this is less than or equal to 48 divided by 6 would be 8. So x here is greater than or equal to 3 and less than or equal to 8. So in interval notation, let me put a 3 here and an 8 here. And I'm going to put a bracket next to each of those because, again, we have non-strict inequalities. So x is greater than or equal to 3 and it's less than or equal to 8. And then graphically, we're just going to match this format. I'm going to find 3, and I'm going to put a bracket there. I'm going to find 8. I'm going to put a bracket there. I'm just going to shade everything in between. So x can be 3 or any number going up to and including +8. Okay, let's look at problem number 9. So here we have -8x minus 8 is greater than or equal to 64 and less than or equal to 72. So again, I want to isolate the -8x part first. So let's add 8 to each part here. And then this is going to cancel. All the way on the left, 64 plus 8 would be 72. This would be less than or equal to, you have -8x in the middle. And then we'll say this is going to be less than or equal to 72 plus 8 would be 80. All right, so what we can do now to isolate x, I have this -8 that's multiplying it. I'm going to divide each part by -8. And when we do this, remember we have to flip the direction of the inequality symbols here. So 72 divided by -8 would be -9. And then this will be a greater than or equal to. This will cancel. You'll have x. This will flip to a greater than or equal to. 80 divided by -8 is going to be -10. So again, when you have this situation, just take the time to rewrite this in the order of the number line. I'll write -10 here, and I'll write -9 here, and x in the middle. So x will basically be greater than or equal to this -10 and less than or equal to this -9. So in interval notation, let's put a bracket. Let's put -10 for the smallest possible value. Then let's put a -9 and then another bracket. So again, each of these values are going to be included. So on the number line here, I don't have a notch for -10. So maybe let's put one in here, something like right there. Let's put that as -10. And this is going to be pretty close, but let's just put a bracket there. And let's put a bracket there. And let's just shade everything in between. So that'd be my solution graphically, basically saying that x can be -10 and then any value going up to and including -9. Okay, let's look at problem number 10, our last problem here. So we have 8 plus x is greater than 9 and less than 12. So let's just subtract 8 away from each part here. Let's see where that gets us. This will cancel. I'll have x is greater than 9 minus 8 is 1. We'll say and it's going to be less than 12 minus 8 is going to be 4. And let's think about the interval notation. So I know that 1 and 4 would not be included because I have strict inequalities. So let's put a 1 here and a 4 here. So a 1 for the smallest value and a 4 for the largest value. But again, these values are not actually included. So we're going to put a parenthesis next to each one just to show that. And then on the number line, let's just match this. So at 1, I'm going to have a parenthesis. And then at 4, I'm going to have a parenthesis. And then I'm just going to shade everything in between. So basically, x can be any value between 1 and 4, where 1 and 4 are not included. Let's take a look at the practice test. We're told to solve each inequality, write in interval notation, and graph. So for the first problem, we have 1 minus 9x is greater than 1 plus 7x. Then we have our keyword and. Then we have x plus 1 is greater than or equal to negative 6 minus 6x. So the idea here, if you get a compound inequality either with and or, you want to solve each inequality separately, and then you want to think about the overall solution. Now, if you have the keyword and, then you want to look for the intersection of the two solution sets. So in other words, all numbers that satisfy both inequalities. Then if you get the keyword or, then you want to look for the union of the two solution sets, so any number that satisfies either. So we'll get to some or inequalities later on. Let's focus on this one. And what I'm going to do is just solve this one up top first. So 1 minus 9x is greater than 1 plus 7x. And so from here, let's subtract 7x away from each side of the inequality. This would cancel. And let's also subtract 1 away from each side of the inequality. This would cancel and this would cancel. Now on the right-hand side, everything canceled. Remember, if you have something like 1 minus 1 or 7x minus 7x, the result of those operations would be 0. So I'm going to put a 0 on the right-hand side of this inequality. This is, of course, a greater than symbol. And then from here, negative 9x minus 7x would be negative 16x. So to finish this up, I'm going to divide both sides of the inequality by negative 16. But remember, if you multiply or divide both sides of an inequality by a negative number, you have to flip the direction of the inequality symbol. So it was a greater than symbol. Now it's going to be a less than symbol. This would, of course, cancel, and you'll have x is less than 0 divided by negative 16 is 0. So this is the first part, but again, we're not done because we have to solve the other one, and then we have to put it together. Okay, so what I'm going to do here is I'm just going to write my keyword and next to this first solution, and then we're going to solve this one. So we're going to have x plus 1 is greater than or equal to, you have negative 6 minus 6x like this. So from here, let's think about adding 6x to both sides of the inequality. And so we see that this would cancel. Let's subtract 1 away from each side of the inequality. We see this would cancel. And so on the left-hand side of this inequality, we see x plus 6x would be 7x. This is greater than or equal to negative 6 minus 1 is negative 7. So to finish this up, let's divide both sides of the inequality by 7. This is going to cancel. You have x is greater than or equal to negative 7 divided by 7 is negative 1. So now we have x is less than 0 and x is greater than or equal to negative 1. Let's grab this real quick, and I'm just going to think about this with you on the number line so that everything makes sense. So with these, it usually helps to put it in the order of the number line. So you can say that since negative 1 is to the left of 0 on the number line, let me write x is greater than or equal to negative 1 first, and then I'm going to put and. I'm going to put x is less than 0. Let me erase this from here. We're going to rewrite this as a three-part inequality in a moment, but for right now, let's just focus on this graphically. If x was greater than or equal to negative 1, what would that look like if I graphed it? I would put a bracket at negative 1. Again, your book might use a filled-in circle. Just do whatever your book does. And then you shade everything to the right. So basically, x there could be negative 1 or anything larger out to positive infinity. What does it look like if I had x is less than 0? Well, at 0, I would have a parenthesis, or again, some books use an open circle, and then I would shade everything to the left going down to negative infinity. So where's the intersection of the two? In other words, which numbers satisfy both? Well, it's going to be starting with negative 1 and going up to but not including 0. That's all it is. So we would erase this if we wanted to graph it properly, and basically, we would just shade in all this right here from negative 1 to 0, and again, 0 is excluded because of that parenthesis. And maybe I can make that a little bit better. So let me try to make it like this. So we can also write this as a three-part inequality. So I'm going to put x in the middle, and then I'm going to first say that it's greater than or equal to negative 1, and then I'm going to say and it's less than 0. So this is how you would write your solution as a three-part inequality. This is how you would graph it. And then in interval notation, you would put a bracket here and a parenthesis here, because again, negative 1, the smallest value is included, okay? Then a comma, and you're going to put 0 here. Again, it's not the actual largest value, so we put a parenthesis next to it to show that it's excluded. So here is your interval notation. This is as a three-part inequality. This is with your keyword and this is graphically. Okay, let's look at the second problem. So here we're going to have 9x plus 10 is greater than 10 plus 8x. And then our keyword and, we have 5x plus 5 is greater than or equal to 8x minus 1. So for this one, let's start with 9x plus 10 is greater than 10 plus 8x. We can see that we have 10 on each side of the inequality. So at this point, you can just cancel it. Again, you could subtract 10 away from each side, but that's really up to you. So from here, I'm just going to subtract 8x away from each side of the inequality. And of course, this would cancel. Again, on the right-hand side, this would be 0. So let's put a greater than there. We have 9x minus 8x, which is going to be positive 1x, or just x. So here we have that x is greater than 0. So let's erase this, and let's write our keyword and let's work on this one now. So we have 5x plus 5 is greater than or equal to, you have 8x minus 1. Let me make this symbol a little bit better. So what I could do is I could subtract 5 away from each side of the inequality. This would cancel. And I could subtract 8x away from each side of the inequality. This would cancel. 5x minus 8x would be negative 3x. This would be greater than or equal to. Negative 1 minus 5 would be negative 6. Now to finish this off, again, since I'm dividing by a negative here, and it's going to be a negative 3, the coefficient of x, I have to flip the direction of the inequality symbol. So this will become a less than or equal to here. This cancels. X is less than or equal to. Negative 6 divided by negative 3 would be positive 2. So again, you can come down to your number line to get a little visualization of what's going on. But I think it's a little bit better if you just start to think about it. Again, x can be any number that's greater than 0. So starting at 0, I would have a parenthesis there because it's excluded. And I would just shade everything to the right out to positive infinity. Then we're saying here x is less than or equal to 2. Well, here's 2. And 2 is included, so let's put a bracket there. And I would shade everything to the left. Well, where's the intersection? Which numbers satisfy both? Well, it's going to be anything that's greater than 0 going up to and including positive 2. So to shade this properly, again, let's just get rid of this. Let me choose a different color, and I'll just shade everything in between here. So anything, again, that's greater than 0 going up to and including positive 2. Again, we can write this as a 3-part inequality by saying x is going to be greater than 0, and it's going to be less than or equal to positive 2. And then an interval notation, again, just match this what you're getting. You're going to have a 0 here and a 2 here. It's just a matter of is it included or not. In the first case, the 0 is excluded. So it's not the actual smallest value, so we put a parenthesis there to notate that. In the second case where we have 2, again, this is a non-strict inequality. We have the or equal to, so the 2 is included, so we'll put a bracket there. So again, here is this guy graphically using the keyword and. We have the 3-part inequality, and then we have our interval notation. Okay, let's look at problem number 3. So here we're given 9x plus 8 is greater than 7x minus 6. Then again, we have our keyword and. We have 6x minus 1 is greater than 7x minus 10. Okay, so let's start with 9x plus 8 is greater than 7x minus 6. Let me slide down here a little bit. So let's subtract 7x away from each side of the inequality. This would cancel. And let's subtract 8 away from each side of the inequality. This would cancel. 9x minus 7x is going to give me 2x. This would be greater than. Negative 6 minus 8 would be negative 14. So let's put negative 14 here. Let's divide each side of the inequality by 2. Of course, this cancels, and you get x is greater than. Negative 14 divided by 2 is negative 7. Let me write and here, and then we're going to take this other guy. So we're going to say 6x minus 1 is greater than 7x minus 10. And let's slide down here. So what I'm going to do now is I'm just going to add 1 to both sides of the inequality and subtract 7x away from each side of the inequality. So let's cancel this guy and let's cancel this guy. 6x minus 7x is going to be negative 1x, or just negative x. This will be greater than. We have negative 10 plus 1, and that is going to give me negative 9. Now again, I would divide both sides by negative 1, or you could multiply both sides by negative 1. Either way, you have to flip the direction of the inequality symbol. So instead of it being a greater than, it's going to now be a less than. So I'm going to divide both sides by negative 1. And so this would be x is less than negative 9 divided by negative 1 would be positive 9. Okay, so again, thinking about this graphically, if I saw x is greater than negative 7 and I was asked to graph it, I would put a parenthesis at negative 7, or once again, an open circle if that's what you want to do. And I would shade everything to the right like this. And if I saw x is less than 9, well, what I would have is a parenthesis at positive 9. And then I would shade everything to the left like this. So where's the intersection of the two? In other words, which numbers would satisfy both? Well, it looks like anything between negative 7 and positive 9, excluding those two endpoints. Let's erase this, and I'll just shade this maybe in a different color here. So I'll shade this like this to show that solution graphically. So again, as a 3-part inequality, we'll put x here. We know that it has to be greater than negative 7 and it has to be less than 9. And then an interval notation, again, I'm just going to use these numbers. So -7, 9. And again, both are going to be excluded. So I'm going to use a parenthesis next to each. So once again, this is our solution graphically. Then we have the keyword and. Then we have the 3-part inequality. And then we have our interval notation. Okay, let's look at problem number 4. So we'll have 7x minus 8 is less than 8 plus 6x. Then we have our keyword and. We have 7 plus x is less than or equal to 3x plus 9. So let's write 7x minus 8 is less than 8 plus 6x first. And we'll come back up in a moment. So let's solve this. Let's add 8 to both sides of the inequality. We know that this guy is going to cancel. And then let's also subtract 6x away from each side of the inequality. This guy is going to cancel. So it looks like 7x minus 6x is just going to give us x, or you could say 1x. And then this is going to be less than, over here, 8 plus 8 would be 16. Okay, so that's the first part. Let's put our keyword and there. Then for the second part, we have 7 plus x, or you could write x plus 7. This is going to be less than or equal to, you have your 3x plus 9. Now let's subtract 3x away from each side of the inequality here. And then let's also subtract 7 away from each side of the inequality. And we'll show this is canceling. We'll show this is canceling. So on the left, x minus 3x is going to be negative 2x. This would be less than or equal to. 9 minus 7 would be 2. As a final step, let's divide both sides of the inequality by negative 2. But again, you can't ever forget this. You have to flip the direction of the inequality symbol because we're dividing by a negative. So this has to be a greater than or equal to here. This cancels. So you have x is greater than or equal to. 2 divided by negative 2 is negative 1. Okay, as I told you before, again, this isn't necessary. But if you're trying to put the solution together, I would look for the smaller number in terms of the number line. So which one is the leftmost? Let's put that first, or all the way to the left. So I say x is greater than or equal to negative 1. And I'll say x is less than 16. And again, when you do that, it makes it really simple to put this into a 3-part inequality format. You have x in the middle. So we would first say, what is x larger than? Well, here we have it's larger than or equal to negative 1. So let's put x is greater than or equal to negative 1. And then what's it less than? In this case, it's going to be strictly less than 16. So this is how you can quickly put together your 3-part inequality. So now we know that x is any number starting from negative 1 and going up to but excluding positive 16. So let's just do the interval notation real quick. Again, we know we're going to use these numbers here. So let's put negative 1, 16. Again, is it included or excluded? This is a non-strict inequality, so it's going to be included here, so I use a bracket. This is a strict inequality, so it's going to be excluded here, so I'm going to use a parenthesis. And then on the graph, because this is a really wide range, and I don't think I can make a graph going from negative 16 to positive 16, I'm just going to notate this by saying, hey, this notch here represents negative 1, and this notch here represents positive 16. And just for the sake of showing this graphically, we can do this. And then I'm going to put a bracket at negative 1. I'm going to put a parenthesis at positive 16, and then I'm just going to shade everything in between. So again, the idea here is that x can be negative 1. Again, negative 1 is included. And then any number going up to and excluding 16. Okay, let's look at problem number 5. So here we're going to have 4 plus 6x is greater than 4 plus x. All right, so we see that we have 4 on each side of the inequality. Again, you can visibly subtract 4 away from each side of the inequality, or you can just cancel it. You know that it would go away. And then we could subtract x away from each side of the inequality. Again, if this cancels over here, you need to write a 0. So let's put a greater than symbol there. 6x minus x would be 5x. So here we get 5x is greater than 0. Let's divide both sides of the inequality by 5. This cancels. You get x is greater than 0. Then for this one, we have negative 8 plus 5x is greater than, we have 5x minus 10. Now we can see that we have the same thing on both sides. So again, if I want to, just to show this so no one gets lost, you can subtract 5x away from each side of the inequality. And let's cancel this, and let's cancel this. So we basically have negative 8 is greater than negative 10. So let's get rid of this. We don't need it anymore. Let's just consider the statement that we're left with. We have negative 8 is greater than negative 10. This is always true. Negative 8 is to the right of negative 10 on the number line, so it's a bigger number. So I could put and, my keyword and, really I would say all real numbers. So all real numbers. And this one might require a little bit of thought. So the first guy is x is greater than 0. So let's put a parenthesis there, and let's shade everything to the right. Okay, so any number that is greater than 0 satisfies this one. Then for the other one, it's all real numbers. So we could shade the entire number line for that. So the entire number line, like this. So essentially, what's the intersection of the two? Well, it would be anything that's greater than 0. So essentially, we would take this guy right here because it's more restrictive. So we would say, let me just get rid of this, and I could probably highlight this in a better color here just to show it. We would say that our solution is going to be that x is greater than 0. Okay, so this guy right here, and then in interval notation, I would put a 0 here, next to a parenthesis, then comma, the infinity symbol, again, because it's going to go out to positive infinity. Okay, let's look at problem number 6 now. So what we have is 8x plus 1 is less than 7x minus 2. Then now we have the keyword or. We have negative x minus 8 is less than 2 plus 4x. So we'll say 8x plus 1 is less than 7x minus 2. Let's subtract 7x away from each side of the inequality. This would cancel. 8x minus 7x would be positive x. And then over here, let's subtract 1 away from each side of the inequality. Let's cancel this. We'll say this is less than. Negative 2 minus 1 would be negative 3. So we get x is less than negative 3. Let's put or. Over here, we have negative x minus 8. We'll say this is less than 2 plus 4x, like this. And so let's add 8 to both sides of the inequality, like this. Let's subtract 4x away from both sides of the inequality. And so what we're going to see is that this would cancel, and this would cancel. And so negative x minus 4x would be negative 5x. And this would be strictly less than. 2 plus 8 would give me 10. So let's divide both sides of the inequality by negative 5. And once again, if you're dividing by a negative and you're working with an inequality, you've got to flip the direction of the inequality symbol. So this was a less than, it becomes a greater than. This cancels. You get x is greater than. 10 divided by negative 5 is negative 2. So let's write x is strictly greater than negative 2. Our solution set contains all numbers that satisfy either. So when we think about it, x could be strictly less than negative 3. So coming to the number line, I could find negative 3, and I could put a parenthesis there, and then I could shade everything to the left. But also, x could be anything that is greater than negative 2. So I could put a parenthesis there at negative 2, and then I could shade everything to the right. So basically, the only numbers that are excluded from the solution set would be the numbers between negative 3 and negative 2 with those two numbers included. But everything else would be a solution for this compound inequality with or. X could be anything less than negative 3, or x could be anything that's greater than negative 2. So in interval notation, this one's a little bit harder to write. You want to think about this left part here. I'm going to say from negative infinity, coming up to and excluding negative 3. So I'm going to use a parenthesis next to each. Let's think about the right part here. So x could be anything that's larger than negative 2. So we'll put negative 2 out to positive infinity, use a parenthesis next to each. And then remember from the lesson, we're going to use the union symbol. So this is not a U, it's the union symbol to connect the two. Okay, let's look at problem number 7. So we have 5x plus 6 is greater than 4x plus 6, then or 5x minus 2 is greater than or equal to x minus 10. So 5x plus 6 is greater than 4x plus 6. And of course, with this, you have 6 on each side. So let's just get rid of it. We know we can subtract 6 away from each side of the inequality legally. Let's just pick up some time. Let's subtract 4x away from each side of the inequality here. This cancels. So on the right-hand side, you want to write a 0 there. Let's put the greater than symbol. And then 5x minus 4x would be x. So here, for the first part, we get x is greater than 0. And let's write or there. So for the next part, we have 5x minus 2 is greater than or equal to x minus 10. And so let's add 2 to both sides of the inequality. This would cancel. Let's subtract x away from each side of the inequality. And of course, this would cancel. 5x minus x would be 4x. And this would be greater than or equal to negative 10 plus 2 is going to be negative 8. As a final step, let's divide both sides of the inequality by 4. This would cancel. We get x is greater than or equal to negative 8 divided by 4 is going to be negative 2. Okay, so I'm actually going to write this one like this. So x is greater than or equal to negative 2, or x is greater than 0. If you think about this first one, x is greater than or equal to negative 2. So let's put a bracket at negative 2, and let's shade everything to the right here. But now let's think about x is greater than 0. Well, here's 0, and I put a parenthesis there, and I shade everything to the right. Well, again, when you think about these two, it's either, right? So it could be that x is greater than or equal to negative 2, or x is greater than 0. So I'm going to take this guy right here as the solution. I don't need the other one. It's already contained within this solution, right? So I can just shade this right here, and I can say that this is my solution. I don't need the or here. You can just get rid of it. I can say x is greater than or equal to -2. And then in interval notation, I can say from -2. And again, this is included out to positive infinity. All right, let's take a look at problem number 8. So we have 5x minus 8 is greater than 7 plus 2x. Then our keyword or. We have -9x minus 9 is greater than -9 plus 9x. All right, so let's take a look at the first part. So 5x minus 8 is greater than 7 plus 2x. Let's think about how to get our solution here. Let's subtract 2x away from each side of the inequality. This would cancel. Let's add 8 to both sides of the inequality. This would cancel. 5x minus 2x would give me 3x, and this would be greater than 7 plus 8 is 15. Let's divide each side of the inequality by 3. This cancels. You get x is greater than 5. Okay, let me write the keyword or here. And then let's look at this part right here. So we have -9x minus 9 is greater than -9 plus 9x. So again, if you have the same thing on each side of an inequality or an equation, you can just get rid of it, right? I could add 9 to both sides of the inequality, and this would go away. So now I have -9x is greater than 9x. Well, again, all I want to do here is subtract 9x away from each side of the inequality. This will cancel, become 0, so make sure you write that. -9x minus 9x would be -18x. So -18x is greater than 0. Divide both sides by -18. And again, because we're dividing by a negative, we've got to flip the direction of that inequality symbol. So this guy right here would cancel. You get x is now less than 0 divided by -18 is 0. So let me write this as x is less than 0 or x is greater than 5. So on the number line, if x is strictly less than 0, I'm going to put a parenthesis here at 0. I'm just going to shade everything to the left like this. If x is strictly greater than 5, I'll put a parenthesis at 5, and I'll shade everything to the right like that. In interval notation, again, it's the union of the two solution sets. So let's say for x is less than 0, we'll say from -infinity coming up to but excluding 0. So like this, we'll have our union symbol. And then for x is greater than 5, we'll put 5 here and then out to positive infinity. Again, everything here is excluded because we have these strict inequalities. Okay, for the next two, we have one with fractions and one with decimals, just to get some practice with that. So let's look at problem number 9. We're going to have -2x minus 4/3 is greater than or equal to 2x plus 3/2. Then we have our keyword or. We have 5/2 x minus 7/2 is greater than -2x plus 1/2. All right, so let's start with the first one. We have -2x minus 4/3 is greater than or equal to, we have 2x plus 3/2. So you could multiply everything by 6. Now, it might be a little bit faster if you wait to do that. So let's subtract 2x away from each side of the inequality. Let's cancel this. -2x minus 2x would be -4x. So then minus 4/3 is greater than or equal to, you have 3/2. So now there's one less term to think about, and you can still multiply both sides by 6. So what happens is, if I multiply this by 6, I get -24x, then minus 6 times 4/3. 6 divided by 3 is 2. 2 times 4 is 8. So this would be -8. This is greater than or equal to. 6 divided by 2 is 3. 3 times 3 is 9. So let's add 8 to both sides of the inequality. This would cancel. And what we're going to have here is -24x is greater than or equal to 9 plus 8 is 17. Now let's divide both sides by -24. And that's going to flip the direction of the inequality symbol. This cancels. X is going to be less than or equal to. We'll have -17 over 24. Okay, 17 is a prime number, so you really can't simplify that any further. Okay, so let's write our keyword or here. And then let's write the other part. So we have 5/2 x minus 7/2 is greater than -2x plus 1/2. All right, so to solve this guy, you see that you have a denominator of 2, 2, and 2. So let's just multiply everything by 2. This would be 5x minus 7 is greater than, this would be -4x plus 1. You can actually just get rid of this. Don't need it anymore. Let's move this up here. And what we'll do is we'll add 4x to both sides of the inequality. This will cancel. And let's add 7 to both sides of the inequality. And then this is going to cancel. 5x plus 4x is going to be 9x. And this is greater than. 1 plus 7 is going to give me 8. And from here, let's divide both sides of the inequality by 9. And so this is going to cancel. And we'll have x is greater than 8/9. Let's go to the number line. And again, for a lot of the problems you get these nice, easy integers to work with. So you can make a traditional number line. For something like this, it's a lot harder to do. So I'm just going to make this notch here negative 17 over 24. And I'm going to make this notch here 8/9. Again, this guy is to the left of this guy, so this is perfectly legal. So to notate that x is less than or equal to this negative 17 over 24, what I can do is just put a bracket here, and then I can just shade everything to the left. Then to notate that x is strictly greater than 8/9, I can put a parenthesis here, and then I can just shade everything to the right. Then for interval notation, let's come from negative infinity. We're going to go up to and including this negative 17 over 24. So this guy is included, so I'm using a bracket. And then the union with this guy, we would have from 8/9. And again, this is excluded, so I'm putting the parenthesis there, and then out to positive infinity. Okay, let's look at problem number 10. So what we have here is 1.6 minus 1.6x is strictly less than 2.3 minus 1.2x. Then we have our keyword or. We have 2.9x plus 2.6 is greater than or equal to 3x minus 0.2. Let me write this one first. So 1.6 minus 1.6x is strictly less than 2.3 minus 1.2x. Now, you know my feeling on decimals if you've watched this series. I don't think it's a good idea to spend time clearing them, but again, your teacher may require it. So let's just do it here for the sake of completeness. So this would be 16 minus 16x is less than 23, and then minus 12x. So you can get rid of that. You don't need it anymore. And then what I'll do is I'll add 12x to both sides of the inequality, just like this. And so this guy right here is going to cancel. And then I'll also subtract 16 away from each side of the inequality. So that guy would cancel. All right, so negative 16x plus 12x would be negative 4x. This is less than 23 minus 16 would be positive 7. What we can do is divide both sides of the inequality by negative 4. Remember, you have to flip the direction of the inequality symbol. So this would be a greater than now. And of course, this right here is going to cancel. So you're going to get that x is greater than, this would be negative 7/4. Okay, so let's list that right there. Then let's put our keyword or. And then let's work on this one right here. If you want, while we're copying it, you notice that you have one decimal place, and one decimal place. You can just multiply everything by 10. So we can say that this is going to be 29x plus 26 is greater than or equal to, this would be 30x, and then minus 2. So from here, let's subtract 26 away from each side of the inequality. So this is going to cancel. And let's subtract 30x away from each side of the inequality. So this is going to cancel. 29x minus 30x would be negative 1x, or you just put negative x. This is greater than or equal to negative 2 minus 26 would be negative 28. Let's divide both sides of the inequality by negative 1. And we know when we divide both sides by a negative, we've got to flip the direction of this. So now it's a less than or equal to. So this would just be x, and this would be 28 over here. So x is less than or equal to 28 here. Let's think about this on the number line. Okay, so let's first think about x is greater than negative 7/4. So let's put this as negative 7/4 here. And let's put this as positive 28 here. Again, if you're not working with integers or you're working with something really big, you could just do something like this to make it simple. If x is greater than negative 7/4, that means I'm going to put a parenthesis here, and I'm going to shade everything to the right like this. If x is less than or equal to 28, I'm going to put a bracket here, and I'm going to shade everything to the left. So remember, when we have the keyword or, it can satisfy either. So in the one case, it's anything larger than negative 7/4. In the other case, it's 28 or anything less. So you can see the entire number line is covered here. So our solution would be all real numbers, right? So basically I can plug in anything from negative infinity to positive infinity and would work in one of these, right? And again, this is a keyword or, so that's all we need. So we can say that our solution is from negative infinity to positive infinity like this. I can actually just erase this, and I can just list my answer as all real numbers, just like this. And what I can do here is just shade the entire number line. You can put whatever numbers you want here or leave it off. I tend to put -1 and +1, but again, you can put whatever you want. And I'm just going to shade this guy like this and just all the way through just to show that the entire number line is covered. So basically, it doesn't matter what we plug in for x, as long as it's a real number, it will satisfy the compound inequality with or. Let's take a look at our practice test. We're told to solve each equation, and for problem number 1, we have the absolute value of x plus 6 is set equal to 1. Now for this type of equation, the first thing we want to do is isolate the absolute value operation on one side of the equation and then have a single number on the other. So in this particular case, we already have that. We have the absolute value of x plus 6 isolated on the left, and we have this 1 that's isolated on the right. Okay, so from here, what do you do? Well, basically, you're going to take the expression inside of the absolute value bars, and you're going to write that. So we'd have x plus 6. And in the first scenario, you just set it equal to this number over here. So it equals 1. So basically, just drop the absolute value bars. Then we're going to write our keyword or, because we're going to be setting up a compound equation with a keyword or. And then the next one, I'm going to drop the absolute value bars again. So I'm just going to take that expression and put x plus 6. But now I'm going to set it equal to the negative of this number over here. So in this case, this would be negative 1. So what I want to do is solve these two equations. And let's go ahead and do that real quick. On the left, I'm just going to subtract 6 away from each side. And so this is going to cancel here. And what I'm going to have is that x is equal to negative 5. Then I'm going to put or. On the right over here, I'm just going to subtract 6 away from each side. And again, this is going to cancel. So what I'll have here is that x is going to be equal to negative 1 plus negative 6 is going to be negative 7. So x could be negative 5 or x could be negative 7. Now, as I talked about in the lesson, there are a lot of ways to notate your solution for this. You could keep it like this if you want. You could write it like this. You could say x is equal to negative 7 comma negative 5. And then you could also use your solution set notation. So you could say negative 7 comma negative 5 inside of your set braces. Again, just get with your teacher in terms of what they want you to do. If you're self-studying, I tend to like this one, but it's really up to you. Okay, I want to check this one with you just so you get an idea of what's going on here. So let's go ahead and write this absolute value of x plus 6 is equal to 1 like this. And in the first scenario, let's choose negative 7. So let's choose negative 7, and let's see what's going on. So negative 7 plus 6 is going to give me negative 1. So I have the absolute value of negative 1 is equal to 1. Now notice that this number does not exactly match this number. But what's going to happen is the absolute value operation is going to fix that for us, because the absolute value operation is going to change negative 1 into positive 1, and so the left and the right side are going to be equal. So this would be 1 equals 1, so this works as a solution, right? Again, because of the concept of absolute value. So let's erase this, and let's erase this, and now if we put negative 5 in there, well, negative 5 plus 6 is positive 1, and the absolute value of positive 1 is 1, so you get 1 equals 1, so this works as a solution as well. Okay, let's look at problem number 2. So here we have the absolute value of x plus 2, and this is set equal to 8. So let's go ahead and say that we have x plus 2 is equal to 8, and then or we'll have x plus 2 is equal to negative 8. Again, we'll just solve these two equations. So I'll just subtract 2 away from each side of the equation here. That'll cancel. And what I'll have is that x is equal to positive 6. Then or, over here, let's subtract 2 away from each side of the equation. And let's say that x is equal to negative 8 minus 2 is going to give me negative 10. So basically, x can be 6 or x can be negative 10. Again, if you check this, 6 plus 2 is 8, positive 8. The absolute value of 8 is 8. Then if you put this one in, negative 10 plus 2 is going to give me negative 8. The absolute value of negative 8 is 8, so 8 equals 8. So both will work as a solution. Again, if you want to write this like this, I'll say x is equal to negative 10, comma 6. Okay, let's look at problem number 3. So this one's a little bit different in terms of the setup. Let's slide down here a little bit. So we have the absolute value of 9x plus 9 is equal to the absolute value of 2x minus 6. So two numbers or two expressions can only have the same absolute value if they're equal to each other or if they're opposites. So I could do something like the absolute value of 3 is equal to the absolute value of 3. This is 3 equals 3. Or I could do the absolute value of negative 3 is equal to the absolute value of positive 3, right? Those would be equal because this guy is going to flip to 3. This guy would stay to 3. So either way, you get 3 equals 3. So I'm going to use that same concept here and just say that in one scenario, I could just drop the absolute value bars. So I could say 9x plus 9 is equal to 2x minus 6. Then or the other scenario is I would basically drop the absolute value bars. So let's go 9x plus 9 is equal to 2x minus 6. And I've got to pick one of these. It doesn't matter which one. And I've got to apply a negative to the whole thing. So wrap it in parentheses and put a negative out in front. It can't be that you just put a negative to one of the terms. You've got to wrap it in parentheses and apply the negative to the whole thing because I want the negative of this expression. So I'm going to subtract 9 away from each side of the equation, and I'm going to subtract 2x away from each side of the equation. Let me slide this keyword or down a little bit so we have a little room to work. So I'm going to cancel this and cancel this. So 9x minus 2x is going to give me 7x. And this equals negative 6 minus 9 would give me negative 15. We can divide each side here by 7. And I'll say that this is going to cancel. X is equal to negative 15 sevenths. Over here, I'm going to apply this negative to each term inside the parentheses. So I'll have negative 9x and then minus 9. This equals 2x minus 6. Let's add 9 to both sides of the equation. And then let's subtract 2x away from each side of the equation. So let's cancel this and cancel this. And let's say that we have negative 9x minus 2x, that's negative 11x. And this will be equal to negative 6 plus 9 is going to be positive 3. And let's divide each side of the equation by negative 11. And so what we'll get is that x is equal to negative 3/11. Okay, so coming back up here, I just erase everything so it would be nice and clean. I'm just going to write the solution as x is equal to negative 15 sevenths. And then also you have negative 3/11. Again, if you want to use the keyword or, you can. I'll let you pause the video on your own and check each of these as a solution for the original equation. You'll see that they both work. Okay, let's look at problem number 4. Same setup as problem number 3. So basically I would want to drop the absolute value bars to start. So I'll have 4 minus 7x is equal to, you'll have negative x and then plus 4. Then you're going to have or. So let me write or. So then you're going to drop the absolute value bar. So 4 minus 7x is equal to negative x plus 4. And then you've got to pick one of these guys. Let's just do this one on the right this time. And you've got to wrap it in parentheses and just put a negative out in front. Let me slide this out of the way. We'll get to this later on. I'm just going to solve this one first, and then we'll slide down. So for this one, let's add x to both sides of the equation. And let's subtract 4 away from each side of the equation. So this is going to cancel, and this is going to cancel. So we can already see that x is going to be 0, but let's just continue. So this is going to cancel over here completely. So on the right, I just have 0. On the left, I have negative 7x plus x. That is going to give me negative 6x. Divide both sides by negative 6. And like I just said, x is going to be 0. So this cancels. And we'll put this over here, or I can just write it here. So x is equal to 0 divided by negative 6 is 0. So let me just write up here, x equals 0. We'll come back up to this. We'll add on to that solution in a moment. Okay, so let me start by just writing the left side. 4 minus 7x is equal to, on the right side, I'm going to apply this negative to each term inside the parentheses. So the negative of negative x is x, right? I'm just changing the sign from negative to positive, and this becomes negative. Right, again, just changing the sign. So from here, let's subtract x away from each side of the equation. So this is going to cancel. And then let's subtract 4 away from each side of the equation. So this guy right here is going to cancel. So negative 7x minus x would be negative 8x. And this is equal to negative 4 minus 4 would be negative 8. Let's divide both sides of the equation by negative 8. And this is going to give us that x is equal to positive 1. So let's put a comma here and just put a 1. So x can be equal to 0. Or also it could be 1. Okay, let's look at problem number 5. So this one's just a little bit more involved, but it goes back to the same concept that we looked at the first part of the video. And essentially you want to isolate the absolute value operation on one side and a single number on the other. So we have 8 minus 7 times the absolute value of 9x minus 2, and this is set equal to negative 6. So the first thing you would want to do here is subtract 8 away from each side. So let's go ahead and do that. And so this is going to cancel over here. And what you'll have is negative 7, and I'll put times the absolute value of 9x minus 2 is equal to, you have negative 6 minus 8, that's negative 14. Okay, so because this is multiplication here, you want to use division to undo it. Again, you're trying to isolate this guy right here. So since negative 7 is multiplying that, you're going to, again, just divide both sides by this negative 7 because it's multiplying. And so this guy right here is going to cancel, and you'll have your absolute value of 9x minus 2 isolated on the left-hand side. On the right-hand side, negative 14 divided by negative 7 is going to be positive 2. Okay, so now we have this set up into the absolute value operation on one side, a single number on the other. So hopefully you remember how to solve this. Essentially, you're going to drop the absolute value bars, and you're going to take this 9x minus 2, set it equal to 2, then or, drop the absolute value bars, so 9x minus 2, set it equal to negative 2. So let's add 2 to both sides of the equation over here. This would cancel. You'll have 9x is equal to 4. Divide both sides of the equation by 9. You get x is equal to 4/9. Okay, then I'll put or. Over here, let's add 2 to both sides of the equation. This is going to cancel. We'll have 9x is equal to negative 2 plus 2 is 0. Divide both sides of the equation by 9. You're going to get x is equal to 0. Okay, so x could be 4/9 or x could be 0. Again, most people will just write this as x equals, let's put 0, 4/9. Okay, let's look at problem number 6, a similar setup to the last one. So what we're going to have here is 6 times the absolute value of 10x minus 1, then minus 4 is equal to 50. So again, I want to isolate the absolute value operation on one side, and I want a single number on the other. Let's deal with getting rid of this minus 4 here first. So let me add 4 to both sides of the equation. And so this would cancel. You'll have 6 times the absolute value of 10x minus 1 is equal to, this would be 54 here. And what I'm going to do is just divide both sides of the equation by 6, since 6 is multiplying this guy. So we'll cancel this with this. And now on the left-hand side, I have the absolute value of 10x minus 1 is equal to, on the right-hand side, 54 divided by 6 is going to be 9. So now that we have this in the format that we want to drop the absolute value bars. So I'll say 10x minus 1 and set it equal to 9. Then or, we want to drop the absolute value bar, so 10x minus 1, and set it equal to the negative of this number, so negative 9. So over here on the left, let's add 1 to both sides of the equation. You're going to get 10x is equal to 9 plus 1 is 10. Divide both sides by 10. And let me show this as canceling here. We'll get x is equal to 1. Then over here, let's add 1 to both sides of the equation. This would be 10x is equal to negative 9 plus 1 is going to be negative 8. Let's divide both sides of the equation by 10. Let's cancel this out. And I'll put my or here. And I'll say that x is equal to, we know this is negative. Let's write 8 as 4 times 2. Let's write 10 as 5 times 2. And let's cancel this common factor of 2 between numerator and denominator. So x equals negative 4/5 like this. So these are our two solutions. X could be equal to, let's put negative 4/5, and then you could put comma, positive 1. Okay, let's look at problem number 7. So here we have 9 plus 2 times the absolute value of 3x plus 7, and this is set equal to negative 37. So what I want to do again is isolate this part right here on one side, have a single number on the other. So let's subtract 9 away from each side of the equation. Then let's cancel this. I'll have 2 times the absolute value of 3x plus 7 is equal to negative 37 plus negative 9 is going to be negative 46. And then from here, I can just divide both sides by 2, and this would cancel. And I'll have the absolute value of 3x plus 7 is equal to negative 46 divided by 2 would be negative 23. Now, I don't need to continue here because, as I told you in the lesson, if you have the absolute value operation isolated on one side and you have a negative number on the other, it's impossible for you to get a solution, right? Because the absolute value operation makes things non-negative. So there's no such value that I can plug in for x here, multiplied by 3 and add to 7. When I take the absolute value of whatever that number is, whatever I can come up with, it's always going to either be 0 or some positive value. It can never, ever, ever be a negative 23, right? So this is not possible. So there is no solution here, okay? And some people like to write the symbol for the null or empty set. Again, we'll talk about this later on in the course. But if you ever get something that sets up this way to where the right side here is negative, again, once you've isolated the absolute value operation, you're not going to have a solution. If the right side was 0, then you would just have one single equation to solve. Okay, let's look at problem number 8. And here we have 4 times the absolute value of negative 3 minus 8x, then plus 2, and this is equal to 118. Okay, so again, just trying to isolate this absolute value operation here. So I'm going to subtract 2 away from each side of the equation. And let's cancel this. We have 4 times the absolute value of negative 3 minus 8x like this. And this equals 118 minus 2 would be 116. Let's divide each side of the equation by 4. Let's slide down here. And let me cancel this guy with this guy. We have the absolute value of negative 3 minus 8x is equal to 116 divided by 4 would be 29. So again, once I get to this setup here, all I need to do is drop the absolute value bars. And I'm going to actually reorder this a little bit. I'm going to put negative 8x minus 3. And then I'll set this equal to positive 29. Then or, I'll have negative 8x minus 3. I'll set this equal to negative 29. So I'm just going to solve these two equations, and let's see what we get. So let's add 3 to both sides of the equation over here. This would cancel. I'll have negative 8x is equal to 29 plus 3 is 32. And let's divide both sides of the equation by negative 8. We'll get x is equal to, this would be 32 divided by negative 8 is negative 4. Let me put or here. Over on this side, let's add 3 to both sides of the equation. Let's cancel this. If I do negative 29 plus 3, that's negative 26. So you're going to have negative 8x is equal to negative 26. Let's divide each side of the equation by negative 8. Let's show this is canceling here. We'll have x is equal to, let's write 26 as 13 times 2. Let's write 8 as 4 times 2. And so we're going to show this is canceling this 2 with this 2. So x would be 13/4 there. So let's put that like that. Or if you want, you can put x is equal to, let's go negative 4, comma 13/4. All right, let's look at problem number 9. So this one looks like it'll be a little bit tedious because of the fractions. We have negative 11 over 10, which is multiplied by, let me show that, multiplied by this absolute value of 3/2 x plus 5/2, then plus 4/5 is equal to negative 147 over 160. So I would start by clearing the denominators. So on the outside of the absolute value operation, and you think about the denominators out there, you have a 10, a 5, and 160. So you can just use 160 as your LCD. And so 160 times this guy right here, 160 divided by 10 is 16, and 16 times 11 is 176. Let me put negative 176 times the absolute value of, you have this 3/2 x plus 5/2, and then plus, if I go 160 divided by 5, that's 32, and 32 times 4 is 128, and this would be equal to, over here, this would be negative 147, because again, I'm multiplying by 160. Okay, so this is all set up. I don't have any fractions anywhere except for inside the absolute value bars, which we'll deal with later on. Let me slide down here. And again, my goal is just to isolate this for right now. So let's subtract 128 away from each side of the equation. And so this is going to cancel. And so what I'll have is negative 176 times the absolute value of 3/2 x, and then plus 5/2. And then that's canceled. So this equals, if I do negative 147 minus 128 in my calculator, I get negative 275. We have this negative 176 times the absolute value of 3/2 x plus 5/2. This is set equal to negative 275. So let's divide both sides of the equation by negative 176 like this. And so this is going to cancel. And we'll say that we have the absolute value of 3/2 x plus 5/2, and this is equal to, negative divided by negative is positive. So let's write 275. I'm actually going to write this as 5. I would start with 5 times 55, so it would be 5 times 5 times 11. And then for 176, I could do 16 times 11. So let me put 11 here times, you can put 16 or 2 to the 4th power if you want. It's really up to you. Let's just put 2 to the 4th power for right now. And we're going to cancel this common factor of 11. So this is going to be 25 over 16. So let's write that as 25 over 16. So from here, it's really not that bad. What I'm going to do is set what's inside of here equal to this, and then what's inside of here equal to the negative of this. So let's say that we have 3/2 x plus 5/2 is equal to 25 over 16. So for this equation, I can clear the fractions by multiplying everything by 16. So 16 divided by 2 is 8. So basically you would have 3x times 8, which is 24x. And then plus, again, 16 divided by 2 is 8. 8 times 5 is 40. And then this equals, obviously the denominator of 16 there would cancel. So this would set up the same for the next one. You would just go or, and this would be negative 25 instead of positive 25. Let me actually just erase this real quick. And then we'll say 24x plus 40 is equal to negative 25. And actually, I should probably just do this over here so I can fit this all. So 24x plus 40 is equal to negative 25. All right, so now let's work on the one on the left. So let's subtract 40 away from each side of the equation. That's going to cancel. I'm going to have that 24x is equal to 25 minus 40 is going to be negative 15. And let's divide each side here by 24. And so I'm going to get x is equal to negative 15. Let's write that as 5 times 3. For 24, let's write that as 8 times 3. And we can see that we can cancel a common factor of 3 between numerator and denominator. So x here would be negative 5/8. So I'm actually just going to erase this and just put x equals negative 5/8 there. And then let me just drag this down here. So we have some room. I'll come back up and answer that completely in a minute. We know this is an or. We can get rid of that. So let's put minus 40 on each side here. Cancel this. We'll have 24x is equal to negative 25 minus 40 would be negative 65. And let's divide both sides of the equation by 24. Let's cancel this. X is equal to, we know this is negative. 65 is 13 times 5. And 24 is basically 8 times 3, so 2 cubed times 3. So no common factors here other than 1. So we're going to have to write this as negative 65 over 24 like this. So let's erase this. Let's put our answer, let's put comma, and we'll put negative 65 over 24. All right, let's look at problem number 10. Again, another tedious one because we have some fractions involved. So we have negative 4/5 times the absolute value of 3/2 x minus 28/9. Then plus 8/5 is equal to 14 over 45. Okay, so thinking about the fractions on the outside of the absolute value bars, again, the LCD there, if you think about 5, 5, and 45, again, don't worry about what's inside the absolute value bars for right now. The LCD is going to be 45. So what I'm going to do is multiply both sides of the equation by 45. And so 45 divided by 5 would be 9. 9 times negative 4 is negative 36. So you'd have negative 36 times the absolute value of 3/2 x minus 28/9, and then plus, if I do 45 divided by 5, that's 9. 9 times 8 is 72. This equals, obviously, if I multiply this by 45, the denominator would cancel, so you just have 14. Okay, you slide down here, and now let me subtract 72 away from each side of the equation. Let's cancel this out. We'll have negative 36 over here on the left times the absolute value of, you have 3/2 x minus 28/9. And then this is equal to 14 minus 72 is negative 58. And then to finish this up, let's divide both sides of the equation by negative 36. And so this is going to cancel. And we'll have the absolute value of 3/2 x minus 28/9 is equal to, negative over negative is positive. For 58, it's 29 times 2. And then for 36, you can think about this as 6 times 6, and 6 is 3 times 2. So basically it's 2 squared, and then multiplied by 3 squared. So what I'm going to do is cancel one of these 2's. So I'll cancel one of those with this. And so this would be 29 over 3 squared is 9 times 2 would be 18. So 29 over 18 would be the simplified fraction there. Let's put this like this. So 29 over 18. Okay, so let's set up our equations. So again, what's inside the absolute value bars? So we have 3/2 x minus 28/9 is equal to 29 over 18. Let's clear the fractions first, and then I'll do the compound equation with or. The LCD here would be 18. So if you multiply everything by 18, then 18 divided by 2 is 9. 9 times 3 is 27, so this is 27x. And then minus 18 divided by 9 is 2. 2 times 28 is 56. And this equals, obviously the 18 there would cancel, so you just have your 29. So let's erase this. And let's say or. We'll take the 27x minus 56. Set this equal to now negative 29. Okay, so let's solve these two equations. Really not that bad. So we will add 56 to both sides of the equation. This would cancel. You'd have 27x is equal to 29 plus 56 would give me 85. And then I would divide both sides of the equation by 27. And so this is going to cancel. We'll have x is equal to, for 85, it's 17 times 5, and 27 is 3 cubed. So there's no common factors other than 1. So we just have to leave it in this format. Let me make the 5 a little bit better there. Now let me solve this one. I'm just going to get rid of this. We know it's an or. Let me move this over here. And we'll come back up and list the solution in a moment. Let's add 56 to both sides of the equation. And let's get rid of this. We'll say 27x is equal to negative 29 plus 56 is 27. And then let's divide both sides of the equation by 27. Let me slide down here. And let's cancel this with this. We get x is equal to 1. And let's just put a comma here and put a 1 here. So x is equal to 85 over 27. And then also it could be 1. All right, let's take a look at our practice test. We're told here to solve each inequality, write in interval notation, and graph. So if we look at the first problem, we have the absolute value of 1 minus 5x is greater than or equal to 36. So when we solve an absolute value inequality, we always want to make sure that our absolute value operation is isolated on one side and we have a single number on the other. So we already have that here. So basically we just go into our rule, and if we have a greater than or equal to or a greater than, then we want to set up a compound inequality with or. So for the first one, it's really simple. Just drop the absolute value bars and copy what you have. So you have 1 minus 5x is greater than or equal to 36. Then you're going to write your keyword or. And then for the next one, you drop the absolute value bars. So 1 minus 5x. You're going to flip the direction of the inequality symbol. So now it's going to be a less than or equal to. And then you're going to change this guy into a negative. So this would be negative 36. So really, you just have to remember to flip the direction of the inequality symbol so it becomes a less than or equal to, and then change this guy into a negative so you get negative 36. Okay, so now pretty much we just have to solve this compound inequality. Pretty easy to do. Let me start over here on the left. I'm just going to subtract 1 away from each side of the inequality. This would cancel, and I'll have negative 5x is greater than or equal to 36 minus 1 is 35. Let's divide each side of the inequality by negative 5. And remember, if I divide both sides of an inequality by a negative, I have to flip the direction of the inequality symbol. So because it was a greater than or equal to, it's going to become a less than or equal to. And let me show this as canceling here. And we'll say that x is going to be less than or equal to negative 7. So I'm actually just going to erase this, and we'll list this as x is less than or equal to negative 7. Okay, over here, I want to solve this guy as well. So let's subtract 1 away from each side of the inequality. This would cancel. We'll have negative 5x is less than or equal to. Negative 36 minus 1 would be negative 37. Let's divide each side of the inequality by negative 5. And remember, if you divide both sides of an inequality by a negative, you have to flip the direction of the inequality symbol. So let's go greater than or equal to here. This would cancel. So you have x is greater than or equal to. This would be 37, which is a prime number, over 5. So let's erase this. So we have our solution that says that x is less than or equal to negative 7, or x is greater than or equal to 37/5. So remember how to write this in interval notation. I'm going to start by saying that x could be anything from negative infinity up to and including negative 7. So let me put a bracket there and a parenthesis there. And then it's going to be the union with this guy right here, which is anything from 37 over 5 out to positive infinity. So again, this is included. So I put the bracket next to 37 over 5. Now, graphically, it's kind of hard to show this because you have a non-integer value here. So typically you have a number line from, let's say, negative 10 to positive 10, something like that. But as you get into more difficult numbers to display, you can just do something like this, just for the sake of showing it. And basically what I want is to show that x could be anything that's less than or equal to negative 7. So let me put a bracket here at this notch. I'll notate this as negative 7. And I'm just going to shade everything to the left like this. And then over here, let's just say this is 37 over 5. And I'm going to put a bracket here facing to the right, and I'll just shade everything to the right like this. Okay, let's look at problem number 2. So this one is a little bit different in terms of the setup. So now we have the absolute value of 10 plus 9x is less than 73. So it's the same idea, but now you're using the keyword and. So you're looking for the intersection of the two solution sets. And what you would do is you would drop the absolute value bars. So you would have 10 plus 9x basically is less than 73. Then you're going to use the keyword and then you would have 10 plus 9x, so just write your expression. You would flip the direction of the inequality symbol, so just like you did before, so now it's a greater than, and you would make this guy negative, so this is negative 73. Now you can solve it like this, but I think it's probably much faster to just write it as a 3-part inequality because you have the same expression here, 10 plus 9x, and 10 plus 9x. So just write that in the middle. So you're 10 plus 9x like this. And we know that it has to be less than positive 73. And it also has to be greater than, okay, so greater than negative 73. So it's probably easier just to set it up in this format. A lot quicker to solve it. Let's get rid of that. Let's slide this up here. And let's go ahead and solve this. Again, for a 3-part inequality, we would do the same thing to each part. And first we would isolate this 9x. So I would subtract 10 away from each part here, just like this. And of course, this would cancel. Negative 73 minus 10 would be negative 83. Let's put that this is less than our 9x, which is less than 73 minus 10 is going to be 63. And what I'll do to get x by itself, since 9 is multiplying x, I'll divide each part here by 9. Just make sure you do it to everything. And let's cancel this with this. So x will be in the middle, and it'll be greater than, you have negative 83 over 9. And I'll say, and it's less than 63 over 9 is 7. Now, in terms of this fraction here, 83 is a prime number, so it's not something you could simplify. Okay, so for interval notation, neither of these guys is going to be included. So let's put a parenthesis here. I'll put negative 83 over 9. And then comma, I'll put a 7, and then a parenthesis here. Again, this is not included, and this is not included. So we're going to match this when we make our graph. So let's put this notch as negative 83 over 9. And let's say this notch is positive 7. And again, neither is included. So let's put a parenthesis here. And let's put a parenthesis here. And then you would just shade everything in between. So let me just shade all of this in between. So what we're saying here is that x can be any value between negative 83 over 9 and 7, with those two values being excluded. Okay, let's look at problem number 3. So what we're looking at here is the absolute value of negative 4 minus 7x is less than or equal to 10. So again, for a less than or equal to, you're setting up a compound inequality with and. And again, you can write this as a 3-part inequality to make it quicker. So let's take the expression inside of the absolute value bars. I'll put negative 4 minus 7x like this. And we'll say that it's greater than or equal to negative 10. And then it's less than or equal to positive 10. Now from here, I want to first isolate this negative 7x. So let's add 4 to each part here. And let's see where that gets us. This is, of course, going to cancel. So I'm going to have this negative 7x in the middle. And I'll say this is greater than or equal to negative 10 plus 4 is going to be negative 6. And we'll say, and it's less than or equal to 10 plus 4 is going to be positive 14. So from here, I want to get x by itself. So let's divide each part by negative 7. And remember, if you divide by a negative and you're working with an inequality, you have to flip the direction of the inequality symbols. So what we're going to do here is say that this is 6 over 7, so positive 6 over 7. This is now going to be a greater than or equal to here. This would cancel. You would have x. This would be a greater than or equal to here. 14 divided by negative 7 is negative 2. Now what I would do is rewrite this guy in the order of the number line. So negative 2 is to the left of 6/7 on the number line. So it should be when we write our inequality. So I'm going to put negative 2, and I'll put this is less than or equal to x, which is less than or equal to 6/7. Okay, so for our interval notation, both of these guys would be included. So let me just put a bracket here. I'll put my negative 2, comma. I'll put my 6/7 here, and I'll put a bracket. So again, both are included. Graphically, I'll just say this notch here is negative 2, and I'll say this notch here is 6/7. And I'll put a bracket here, and I'll put a bracket here. And then let's just shade everything in between. Again, this is just telling us that x can be any value from negative 2 and including negative 2 up to and including 6/7. All right, let's look at problem number 4. So here we have the absolute value of 5x minus 10 is less than 5. So again, same situation as the last problem. What I'm going to do is take my expression inside the absolute value bars, so the 5x minus 10, and I'll say that this is greater than negative 5 and less than positive 5. And again, very easy to solve this. I'm just going to add 10 to each part here just to isolate the 5x to get things started. And so, of course, this would cancel. You'll have 5x is greater than negative 5 plus 10 is going to be positive 5. We'll say, and it's less than 5 plus 10 is going to be 15. So from here, let's divide each part by 5 so that we can isolate x in the middle. And of course, this is going to cancel here. So let's show that as canceling. And we'll have x is greater than 5 divided by 5 is 1. We'll say, and it's going to be less than 15 divided by 5 is 3. Okay, so x is greater than 1 and less than 3. In interval notation, let's put a 1 here and a 3 here. Again, with a parenthesis next to each because they're not included. And let's just mark this notch as 1. We'll say this notch is 3. And what I'll do here is just put a parenthesis here at 1. And I'll put a parenthesis here at 3 as well. And again, I'm just going to shade everything in between. So x here can be any value between 1 and 3, with 1 and 3 being excluded. All right, let's look at problem number 5. So here we have the absolute value of 6 minus 3x is greater than 3. So again, since we have the absolute value operation isolated, and we have a greater than, we're now going to go back to a compound inequality with or. So I'm going to have 6 minus 3x is greater than 3, or I'm going to have 6 minus 3x, remember, flip the sign, so it's less than, change this to negative, so it's negative 3. So let's subtract 6 away from each side of the inequality here, and let's cancel this. We'll say negative 3x is going to be greater than 3 minus 6 is going to be negative 3. And let's divide both sides of our inequality by negative 3. Remember, this requires us to flip the direction. Right now it's a greater than, so it's going to become a less than. This would cancel. So I have x is less than, -3 divided by -3 is +1. Okay, so the first part is done. X is less than 1. Let's go over here and work on this part now. So I'll say subtract 6 away from each side of the inequality. And of course, this would cancel. You'll have -3x is less than -3 minus 6 would be -9. Let's now divide each side of the inequality by -3. And of course, if we're dividing by a negative, we have to flip the direction of the inequality symbol. So this will now be a greater than. This will cancel. And so what I'm going to have here is that x is greater than -9 divided by -3 is +3. So our solution is x can be any number that's less than 1, or x can be any number that's greater than 3. So in interval notation, we would say from -infinity up to but excluding 1. So let's put a parenthesis there to exclude 1, put a parenthesis there. We'll make our union symbol, and then we'll have our 3 out to +infinity. Again, I'm going to exclude that with a parenthesis, and then I always use a parenthesis with infinity or -infinity. Now, graphically, I'm just going to really match this, and basically I'm going to put a parenthesis here, right there, and I'll say that this is +1, and I'll shade everything to the left here. And then over here, I'll say this is +3. I'll put a parenthesis there, and I'll just shade everything to the right. So again, all we're saying is that x can be any number that is less than 1, or it could be any number that is greater than 3. Okay, let's look at problem number 6. So these are going to start to get more involved now, so more steps. So here we have 8 times the absolute value of 3x plus 4, then minus 1. This is less than or equal to 55. All right, so in all the previous problems, the absolute value operation was already isolated for us. So we have the absolute value of some expression, and then we had either a greater than or equal to, a less than or equal to, but then on the right-hand side, we had some number. So that's the form we want to get this into first before we do anything else. So if I want to isolate this right here, then what I would do is I would first think about, well, I have this -1 here that I need to get rid of. So let's add 1 to both sides of the inequality, and this would cancel. And what we'd have is 8 multiplied by the absolute value of 3x plus 4. And this will be less than or equal to 55 plus 1 would be 56. Now from here, you see that 8 is multiplying what I want to isolate. Again, my goal is to get this on one side by itself. So what I can do is I can just divide both sides of the inequality by 8. And we know that this guy right here is going to cancel. And what we're going to have is the absolute value of 3x plus 4. And this is now going to be less than or equal to 56 divided by 8 is going to be +7. So now we have this into the form of something we know how to solve. Because this is a less than or equal to, we're thinking about a compound inequality with and so we can just use our 3-part inequality format. I'm going to put this guy in the middle, so 3x plus 4. It will be greater than or equal to the negative of this number, so -7, and it will be less than or equal to this +7. So let's solve this by first isolating the 3x part right there. So I'm going to subtract 4 away from each part here, and let's cancel this. And now we'll say that 3x is greater than or equal to -7 minus 4 would be -11. And then this is less than or equal to 7 minus 4 is going to be +3. So let's finish this up by dividing each part here by 3. And what that's going to do is isolate x in the middle. So I'll say x is greater than or equal to -11 over 3. Can't simplify that at all. And I'll say and it's less than or equal to 3 divided by 3 is 1. Okay, so in interval notation, what I would want to do here is put a bracket and then my -11/3, then comma, my +1, and then a bracket. Right? Each of those numbers are going to be included. So again, we match this format when we graph. Let's say this notch is -11/3. Let's say this notch is +1. And then again, let me change back to orange. And I'm just going to put a bracket here. I'm going to put a bracket here. And I'm going to shade everything in between. So x can be any value starting from -11/3 and including -11/3 up to and including +1. Okay, let's think about number 7 now. So we have the absolute value of 3 plus 10x minus 6 is less than or equal to 41. So remember, we need to isolate the absolute value operation on one side. Right now we have this -6 that's being done to it. So let's add 6 to both sides of the inequality, and this would cancel. And what we'll have here on the left is the absolute value of 3 plus 10x, and this is less than or equal to 41 plus 6 is 47. All right, so again, we have a less than or equal to, so we know we're going to use a compound inequality with and, or set this up as a 3-part inequality. So I'm going to do 3 plus 10x here. And we'll say this is greater than or equal to. I'll put the negative 47 here. And we'll say, and it's less than or equal to positive 47. Now what I want to do is isolate this first. So let's subtract 3 away from each part of the inequality. And let's cancel this. So what is negative 47 minus 3? That's going to be negative 50. We'll say this is less than or equal to. We have this 10x here, which is less than or equal to. 47 minus 3 is going to be 44. And so now, as a final step, let's divide each part here by 10. And that's going to completely isolate x for me. So this would cancel. And what I'd have here is that x is greater than or equal to negative 50 divided by 10 is going to be negative 5. We'll say, and it's less than or equal to. You have 44 over 10. Let me write 44 as 22 times 2. And let me write 10 as 5 times 2. And we see that we have a common factor of 2. So let's cancel that out. We'll say this is 22 fifths over here. So basically, x is greater than or equal to negative 5, and it's less than or equal to 22 fifths. Okay, so in interval notation, let's put a bracket here. Let's put a negative 5. Let's put a comma. Let's put our 22 fifths like this, and let's put a bracket. So each of these guys is going to be included. Let's put a negative 5 here at this notch, and let's put a 22 fifths here at this notch. And let's put a bracket here, and let's put a bracket here. And again, let's just shade everything in between. So x can be any number, starting with negative 5 and including negative 5, going up to and including this 22 fifths. Okay, let's look at problem number 8. So here we have 7 times the absolute value of 8x plus 10, then minus 3. This is greater than or equal to negative 45. So what we want to do again is isolate the absolute value operation on one side. So first I would add 3 to both sides. So let me add 3 here and also here. So to both sides of the inequality, this would cancel. And then over here on the left, I'll have 7 times the absolute value of 8x plus 10. This will be greater than or equal to negative 45 plus 3 is going to be negative 42. Now let's slide down here. We still need to get rid of the 7 that is multiplying this guy. So what I can do is I can divide both sides of the inequality by 7. And we'll cancel this with this. And we'll say the absolute value of 8x plus 10 is greater than or equal to negative 42 divided by 7 would be negative 6. Okay, now let's stop for a minute. We have the absolute value operation isolated on one side, and we have a negative value on the other. So we know if this was an equation, there would be no solution, right? Because there's no possible way that the absolute value operation can give me something that's negative. But in this particular case, we don't have an equation. We have an inequality. So we need to use some simple reasoning here to get our solution. It's not true that this guy right here could ever be equal to negative 6. So this part would never work. But could it be greater than negative 6? Yes, it always would be greater than negative 6 because the result of this would be non-negative, right? So the absolute value of some number or some expression, let's just call it a, is always greater than or equal to 0. Okay, so this would be 0 or some positive value, and 0 or some positive value is always greater than some negative value. So what I can say here for this solution is that it's all real numbers. So all real numbers, right? Anything I want to plug in for x, as long as it's a real number, basically it will work. All right, so we can actually notate this in interval notation just by putting a negative infinity here on the left, and then a positive infinity here on the right. And then we can show this graphically by just shading the entire number line. It really doesn't matter for these notches. I'm just going to put -1 and +1. Again, you can put whatever you want, or you can put nothing. You're just going to shade the entire number line just to show that every single real number would be included in your solution set. All right, let's look at problem number 9. So we have the negative of the absolute value of 7x minus 8, then plus 2. We're saying this is less than or equal to negative 32. So I just want to warn you in advance, just because we see a negative here on one side of the inequality, that doesn't mean that we're going to have a special case scenario. Always go through your steps and isolate the absolute value operation on one side and have a single number on the other, okay, before you make any decision about that. So here, if I want to isolate this guy right here, what I would do is I would first get rid of this plus 2 here. And to do that, I'm just going to subtract 2 away from each side of the inequality. So this would cancel. And what I'm going to have here on the left side, instead of a negative, I'm just going to put a -1. So this is more clear. Then times the absolute value of 7x minus 8, like this. Let me make this 8 better here. And then we'll say is less than or equal to negative 32 minus 2 is going to be negative 34. And then from here, let me get rid of this negative 1 that is multiplying this absolute value operation. So let's divide both sides by negative 1. Of course, you could multiply both sides by negative 1. It's whatever you want to do. You're going to have to flip the direction of this either way because we're multiplying or dividing by a negative number and we're working with an inequality. So this is going to be a greater than or equal to now. This over here is just going to cancel out. So we have the absolute value of 7x minus 8 is going to be greater than or equal to negative 34 divided by negative 1 is going to be positive 34. Okay, so from here, we see that we have a greater than or equal to. So we're going to set up a compound inequality with or. So I'm going to first say that 7x minus 8 is greater than or equal to 34. Let me make this 34 better. And then we'll say or. We'll say 7x minus 8 is less than or equal to negative 34. So we're just going to solve this guy. And let me start out here on the left. Let me add 8 to both sides of the inequality here. So you would have this cancel. 7x is greater than or equal to 34 plus 8 is going to be 42. If we divide both sides of the inequality by 7, this would cancel. You get x is greater than or equal to 6. Now over here, let me add 8 to both sides of the inequality. This would cancel. You have 7x is less than or equal to negative 34 plus 8 would be negative 26. And let's divide both sides of the inequality by 7. This would cancel. And so you're going to have x is less than or equal to negative 26 over 7. So let me write this as x is less than or equal to negative 26 over 7. You can't simplify that. 7 is a prime number. And then I'll say or x is greater than or equal to positive 6. So in interval notation, I want to first say that from negative infinity coming up to and including this negative 26 over 7. So I'm going to put a bracket there because it's included. And then again, you want your union. So the union with this other guy. So we're going to start here with positive 6. That's the smallest value that it can be, and it's included. So we have the bracket, and then out to positive infinity, like this. So then on this guy right here, let's say this is negative 26 over 7. Let me move this out of the way and just drag this over here. And let's say this is positive 6 here. Let me grab like an orange. So I'm going to put a bracket here that faces to the left. So it could be negative 26 sevenths, or it could be anything going to the left out to negative infinity. It could be positive 6 over here. So let me put a bracket there, and then let me shade everything to the right. So again, this is going out to positive infinity. Okay, let's look at the last problem here, problem number 10. So we have negative 6 times the absolute value of 7 minus 6x, then plus 2, and this is greater than or equal to 68. So again, I want to first isolate this guy right here. So what I'm going to do, since I have this plus 2 over here, let me subtract 2 away from each side of the inequality. This is going to cancel. We'll have negative 6 times the absolute value of 7 minus 6x. This will be greater than or equal to 68 minus 2 would be 66. So from here, I've got to get rid of this negative 6 that is multiplying this guy. So let's divide both sides of the inequality by negative 6, just like this. So this is going to cancel. And remember, if you divide both sides by a negative, you have to flip the direction of the inequality symbol. So let me write the absolute value of 7 minus 6x here. Instead of a greater than or equal to, this is going to be a less than or equal to. And then 66 divided by negative 6 is going to be negative 11. Now, let's pause here for a moment. We saw earlier that if we had the absolute value operation isolated, and we had a greater than or equal to, or greater than, and you had a negative on the other side, well then the solution was all real numbers. Because no matter what you plugged in for x, once you go through all the operations and take the absolute value, you're always going to get something that is 0 or positive, and that's always, always, always going to be greater than some negative value. Well, here you have a less than or equal to. It's not going to be equal, and it's not going to be less than. It's not possible. Because again, the result of this is either 0 or some positive value, so that can never be less than a negative, and it can never be equal to a negative. So for this type of problem, there is actually no solution. Okay, so no solution. Again, some people like to write the symbol for the null or empty set, and once again, we'll get to that later on in the course.